YouTube, and we're going live on the radio. So there we go. So we are live because it's 4:30, so it's automatically gone live. So whatever you say now is going out to 250,000 people around the world.
Hello, 250,000 people
around the world.
Around the world.
not just in England, and Ireland and Scotland. Yep, it's live on YouTube.
Okay, excellent. So let's get sharing then.
And I shall start the recording up here. Away you go.
Okay, super. Okay, so good afternoon, everybody. My name is Alex Binks, and today, well, in the UK, we would have been hoping to observe the Great Conjunction in many places. As it happens, typical of the UK weather, it's looking a little bit grey outside, but we'll still do our best. And any gaps that we get in the clouds, we'll go over to some live observing. With us tonight is Jacco van Loon, who's at the Keele University Observatory, and he is heroically looking for any gaps in the cloud to see if we get anything. So, hi Jacco, hope you're doing well. But we'll still do our best.
Hi everyone.
Excellent. Also with me tonight, we've got some astronomers from Keele University who are going to share, well, a few nuggets of wisdom about Jupiter and Saturn and some of the planets that might be outside of the solar system too. So we've got that to happen in the second hour. Now, of course, 2020 has been somewhat of a tough year for the vast majority of us across the world. I do hope that during this presentation, we find you all in good health and doing well wherever you are. It comes in part of the parlance of 2020 is social distancing. This is a term that's come up quite often, and it's one that is being rudely violated right now by Jupiter and Saturn. They refuse. They're getting closer and closer by the minute. And we expect at 6:37 Greenwich Mean Time that we'll actually arrive at the closest passage.
Hello, yeah, I'm really excited to be able to see this live broadcast of the Christmas Star. It'll be very interesting.
It's one that is being brutally violated right now. Okay, I'm just getting a little feedback, so I'm just working on that as well. Right, so the Great Conjunction is a really interesting event that we're going to be observing. And like I say, we've got astronomers across Keele trying to observe it. So let's see how we do. Now, what better way to introduce this than have the children of Nantwich Primary Academy to let us know what the Great Conjunction is.
Alex, you haven't shared your sound.
I need to share sound.
Wait, when you share screen, you need to take the thing for sharing sound on you.
There's a share sound as well.
Basically, you'll have to unshare the screen.
And
then share again, and you'll see as when you share, you'll see a little box come up, and it says include computer sound.
Gotcha. Yeah.
Yeah, we had this the other day.
Yeah. Okay, let's go again then. So this is the children of Nantwich Primary Academy introducing to you why we call it the Christmas kiss.
On December the 21st, Jupiter and Saturn will come together and look bigger than ever. The two planets will shine bright in this night. In 800 years they have never looked so close like tonight.
The brightest star that people have ever seen, shining bright as they unite, making all of our fears disappear as we stare into the moonlight.
By evening on the shortest day of the year, the stars will twinkle in the sky as Christmas comes near. There'll be one big Christmas kiss this year.
Well, what an excellent introduction by the kids. They always do it better than we ever could. So let's go through what will be happening during our celebration. So this is certainly a once in a lifetime experience for the vast majority of us. This great conjunction of 2020 is going to be the closest one that has occurred in almost 400 years. But for the youngsters around you, if you're still going to be around in 2080, you will also be observing a very similar one. So I'll show you this later on. So we're going to go over what is a great conjunction, how do they occur and why do they happen? And then a little bit about the history and how the Great Conjunction has been connected to some very interesting stories through humanity. One of these, as you may have read in your newspapers or in the media, is this strong connection it has to the Star of Bethlehem. With it being Christmas, what better time than to celebrate a great conjunction along with the Christmas story? So that's something that we're looking forward to. And then we'll have a little chat about how to observe this, where we should be looking, and with different types of equipment, how we can observe it and what we can expect to see if we have a break in the clouds, of course. So this is the weather permitting part, the live observing. We'll see what we can do. And then we got some interviews with astronomers at Keele University, where we're going to be chatting about Jupiter and Saturn, their histories, and also what it's like to be an astronomer as well in day-to-day life. Now, I want this to be a very open, kind of accessible to everybody out there kind of celebration. So this Q&A session, we're going to have it open all the way throughout the next 2 hours. So any questions that you have, if you can pass them over to Pete, who's the DJ at this station. Hi, Pete. Yeah. So if we get the questions through there, we'll do our best to answer them at the end. So you may have seen that the world is watching. This was something I put up about an hour ago, just looking online at the different news articles of the day. And it seems that every country across the globe has some kind of great conjunction story happening. In fact, it's so important that it's today's Google Doodle. So when you've got Google as its main image, well, it must be a newsworthy event. Right, so I'm going to pass this on now to one of the students at Keele University, Jordan Richmond, who's very kindly put some slides together to actually explain to us, well, what properties do Jupiter and Saturn have? So, Jordan, you take it away. Hi.
So yes, Jupiter and Saturn, two of the most wonderful planets in my own opinion. So looking at Jupiter,
Jordan, you've muted yourself.
have I? There we go. Is that better?
That's okay. You're good now, Jordan. Don't worry.
There we go. In true Chris Whitty style, could I have next slide, please?
You absolutely can.
So Jupiter also could be called the king of the planets, the largest planet in our solar system, a gas giant, only shy of being a star itself. but just didn't have that mass. So it's the fourth brightest object in the night sky. That's before the Sun, the Moon, and Venus. So it is quite easy on a clear night to see Jupiter. It also has one of the shortest days of all the planets, just 10 hours. So if you think Mondays lag quite a bit, go to Jupiter. It's, as I'm sure you can see from the images you might have seen previously, it has some quite unique cloud features, and you can clearly see the bands along the atmosphere. Very, very beautiful, very, very colourful as well. It also has what I think everybody associates with Jupiter, the Great Red Spot. That is one hell of a storm that has been raging on Jupiter for quite a long time now. And just to give some perspective on how big that storm actually is, you could fit at least 1.5 Earths inside it. It's that big. You certainly won't want to be caught up in that, I'm sure. I don't have to say. It might look like it's just one big ball of gas, but Jupiter itself actually has a small rocky center. It also has, if my memory does serve me, a liquid metal core along with a rocky core. The outer atmosphere of Jupiter, though, is mostly comprised of hydrogen and helium, along with a few other atmospheric gases. Now, obviously, Jupiter is not just Jupiter on its own. Jupiter has its own moon systems, and quite a large moon system, to be precise, over 50 moons. And one of the largest is Ganymede. Ganymede is not only the largest moon of Jupiter, but it's the largest moon in the entire solar system. It's even larger than our moon. And it's about 1.25 times that size of Mercury. So it's even larger than one of the planets. Now, not many people do know this, but Jupiter does actually have a thin ring system. It's not as big and beautiful as Saturn's, but there's been some spacecraft that has identified its ring system, and there's about 4 rings that orbit the planet. So Jupiter, on the whole, is it's quite a beautiful world. Now, Saturn, on the other hand, is even more incredible. As I'm sure you can see, one of its defining features is its beautiful, beautiful ring system. Next slide, please. So Saturn is one of the planets that we can still see with the naked eye, but only clearly with the naked eye. So yeah, as it says, if you've got good eyesight, you might be able to spot it. Saturn was known to the ancients, just as Jupiter was. The Babylonians and the far eastern observers have recorded it hundreds of years ago. Now, Saturn, like Jupiter, has an atmosphere that's divided into cloud bands. And again, it's mostly made of hydrogen and helium, but there are a few other atmospheric gases in there, such as ammonia and nitrogen. Saturn, as I've already said, has one of the most extensive ring systems, and it's beautiful. It's mostly made of water and ice and rock, and it's believed to be formed from one of Saturn's moons that broke up early in its evolution. But it's not going to last for much longer, unfortunately. It's slowly diminishing. One of the missions to Saturn identified that one of the moons may be feeding one of the rings, which that is pretty incredible, because hopefully it means that the rings will stay there for a bit longer. Just like Jupiter, there are quite a few moons as well, and little moonlets, as we call them. So there are a few missions to both Jupiter and Saturn, hopefully in the future, that will be looking at these small, cold, icy worlds. So hopefully, if anybody has a clear viewing, we'll be able to see these two beautiful planets in their wonderful 2020 conjunction.
Well, that's just fantastic stuff there, Jordan. Thank you very much for sharing that with us. Jordan will be on hand all the way through this show to help out with any questions to do with, well, the practical side of observing. I'm sure Pete can help and many of us here, but Jordan's very happily offered to do some observing himself as well. It's just the clouds at the moment that's getting...
Unfortunately, yes.
Yeah. So a good place to start is to ask ourselves, what is a conjunction? So in very basic astronomical terms, this is just when two celestial bodies appear very close to one another along the line of sight as viewed from the Earth. So this can happen quite often with stars, with asteroids, moons, but we'll be talking about planets in particular. As you can see, well, sorry, radio listeners, but what we have is an animation showing the inner planets of the solar system, Mercury, Venus, Earth, and Mars. And because they're so close to the sun, they have shorter orbital periods. It takes them longer to do one circuit around the sun than it does for the inner planets. So you get more conjunctions that occur around the planets that are closer to the sun. Indeed, in the last 20 years, there have been 160 planetary conjunctions in the solar system, with more happening in the inner planets than there are in the outer planets. So basically, a great conjunction is a conjunction between Jupiter and Saturn. And there's no other complicated part to it apart from that. So this conjunction that's occurring in 2020 is a very special one. And what we found is it happened to get closer around June. And then as the Earth does its orbit around the sun, it overtakes Jupiter. And then the planets then realign as the sun is to the east. So the conjunction is occurring today, as we know, at 2020, 21st of December. And the closest point of approach is going to be at 6:37 GMT. So they've been getting closer and closer. It's not just tonight where they're going to appear close. In fact, back in October, they were around 6 or 7 degrees apart. And as of tonight, they're going to be a mere 1/10 of a degree. Now, just for listeners and viewers, to put that into context, the size of the moon, as viewed on the sky, is about half of a degree. So really, the conjunction that will occur tonight is going to be 1/5 of the size of the moon. So it's really tiny distance. It turns out that people with good eyesight, you'll be able to resolve this just about, but it's going to look quite fuzzy. You won't be able to resolve it behind clouds, which is unfortunate at the moment, but for those of you out there that do have clear skies, well, check it out and let us know how it looks, please. Yeah, so 1/5 of the size of the moon. It's just truly remarkable how close these things will get. So this is just the only part of maths or physics really that I'm going to go through, but a question that we get asked a lot is, how do great conjunctions actually occur? To answer this, we actually have to look at the orbits of Jupiter and Saturn and understand how often they will be at a position relative to the Earth where they would appear aligned. So we know that Jupiter takes 11.86 years to travel once around the sun. And for Saturn, that's 29.46 years. So that's almost 30 years for Saturn. Each time there is a conjunction, the time between those successive conjunctions is something that is known as the synodic period. So it turns out to be 19.85, almost 20 years for Jupiter and Saturn. And I assure you that the only equation that the viewers can see right now, that's all we're going to see tonight with equations. It's Christmas. We don't want to go through hard physics. So as it turns out, around 20 years, and if you remember, Saturn takes about 30 years. So that is about 2/3 of Saturn's orbit. So if you treat that as 2/3 of a full rotation, well, that's about 120 degrees or 240 degrees, however you project that on its orbits. So every third great conjunction occurs with Jupiter and Saturn almost repeating their positions. It makes a kind of equilateral triangle shape, or if you like, in a circular kind of orbital pattern. Now, the exact period can vary due to Earth's motion and the fact that the planets aren't perfectly aligned in a two-dimensional plane. So those orbits do differ ever so slightly. It's not really from the pull of other planets that are close to them. So the other gas giants like Uranus and Neptune, they don't have that effect where they pull on Jupiter and Saturn's orbit so much. So this is an animation showing those different orbits for the 21st century. So there was a great conjunction that occurred in 2000 that unfortunately was too close to the sun really to be observed. We're just going past one that was in 2020. And as we speed this video through the 21st century, we see another conjunction that occurs around 2040. And this is already making a kind of triangular shape. Other car manufacturers are available, but the car Mercedes-Benz does spring to mind when we look at these kinds of plots. So as we can see, every third conjunction, the position repeats itself. So let's have a look at the century that just passed, the 20th century, events that were happening at the time and how well those conjunctions were observed. This really helps us put into context how amazing this one will be. So let's go back to the year 2000, May the 31st. Number one in the charts was a young Britney Spears and also a young Tony Blair, was the Prime Minister of the UK. It turns out that this was very difficult to observe. Saturn was very close to the sun, so we didn't really get many sightings of it. As everybody knows in the amateur and professional astronomy world, never point a telescope near the sun. It's very dangerous. So we didn't really get much from 2000. 1981 in the UK charts, Adam and the Ants were rocking their way to number one with Prince Charming. Pete's looking in disgust at Adam and the Ants as well, but I'm sorry, they were number one. I do like them. This occurred with a triple conjunction. This is where within a 6 to 7 month period, there appear to be 3 conjunctions that occur consecutively. Then we need to go back to 1961, which was probably the last observable great conjunction. So Elvis was up there with the wonder of you, and Yuri Gagarin had just celebrated being the first man in space. So this was easy to observe, and this was around half a moon diameter apart. So we're talking about 1/4 of a degree separated on the sky. Back in the 1940s, yet another triple conjunction, not quite as close this time, 2.5 moon diameters. So quite close, but not so spectacular perhaps compared to this year's. 1921, Albert Einstein had just received his Nobel Prize for Physics for the photoelectric effect. It was too close to observe, and they were 6 moon diameters apart. And finally, 1901, Queen Victoria was on the throne. Elgar had just finished his Pomp and Circumstance Marches 1 and 2. It was easy to observe. So it gives you an idea that there were only really 3 great conjunctions in the 20th century that were observable, but none of them were anywhere near as close as they are at the moment in 2020. So I briefly mentioned the triple conjunction, and we'll come on to this later on, why I'm mentioning why triple conjunctions are relevant to this talk. So, like I said before, this occurs when Jupiter and Saturn pass past each other around 3 times. Well, it happens 3 times, it's a triple, in around 6 or 7 months. And they're rarer than normal conjunctions, and they're quite sporadic. They don't have any particular pattern to them. So the last 3 that occurred were 1981, which is what you can see in the animation if you're watching this, one in 1940 and one in 1821. We're not going to see anything like this again for another 200 years. So they're quite random, really, when they happen. And this is due to the retrograde motion when the Earth passes past Jupiter, but Jupiter overtakes Saturn in its orbit. So that defines what a triple conjunction is for you. So we can ask ourselves, we know that they occur approximately every 20 years, but how often do they get really close, like they do at the moment in 2020? So lo and behold, in 60 years' time, for the youngsters out there, like we mentioned before, you're in luck. You might get a chance of observing this again, and there might be less cloud cover. That's definitely a possibility. And it will be situated away from the sun. So it's going to be more observable higher up in the sky than the 2021. So you might be in luck there in 60 years' time. So the last seriously close conjunction was in 1623. And then the closest one that happened in the millennium, the second millennium, was in 1226. So I'd just like to run over a couple of the facts and figures about this, because they have a really interesting connection with the stories of the day and how humanity really treated astronomy and astrology at the time. So if we take a little look back, don't think many of us remember 1623 out there. There might be some viewers close, but maybe not quite that far. 1623, the Mayflower had just returned on the shores of Plymouth in the UK after finishing its first pilgrim voyage. Hallelujah, the flushing toilet had just been invented. And this was when the last great conjunction occurred, which was within 1/10 of a degree. Bit of news for me, it turned out that a lot of people say Galileo invented the telescope. It's probable that the telescope had been invented in other cultures around the world well before then. The idea of getting an eyepiece and looking out on the sky and recording it is surely older than 400 years old. I'll leave that one for a discussion for later, though. But it was in 1608 that Hans Lippershey patented the telescope. Not invented, but patented it. And 2 years later, Galileo discovered the 4 moons that are easy to observe around Jupiter. These are Io, Europa, Ganymede, and Callisto. He also noticed a fuzzy structure around Saturn that he referred to at the time as ears. And he thought that these were 2 moons that were very close to Saturn. I wasn't quite right, though. It took another, approximately 50 years for the Dutch astronomer Christian Huygens to identify them as Saturn's rings. And in the process, Huygens also identified a moon around Saturn called Titan. This is the largest moon in the Saturnian system. So we can ask ourselves, okay, Galileo had the telescope. He was pointing at all these moons and discovering things, but did he actually observe the conjunction? Well, he probably didn't. There's no actual records of it. And that conjunction, when you trace the orbits back, it appears that Saturn was only around 13 degrees from the sun. So even though it was really close, they were a bit unfortunate back then because it was too close to the sun. For us, what this means is, and this is a really interesting one to take into account, we are the first people who have ever observed such a close great conjunction through a telescope and been able to record it. And part of this celebration that I'll get onto later is really showcasing some of the amazing images that have been sent in to me in the past couple of weeks from just budding astronomers around the world. So I want to do a little diversion now into astrology. I am not an astrologer, and it's Christmas, and I want to be kind. So I will say that astrology is the study of astronomy for thinking of wishy-washy ways of describing the world. There you go, I said it, sorry. Now, the reason I'm talking about astrology for a second is we're going medieval now, and we need to go back to the days of Johannes Kepler. He was a real scientific revolutionary. He was the first to prove that the sun is at the center of the solar system. Copernicus had put forward the idea and many others beforehand, but Kepler was probably the most famous to put the first parts of proof towards it. In finding this, he actually discovered planetary laws of motion, basically describing not just that planets go around the sun, but how they go around the sun. He was also one of the first to explain the tides that were how they were caused by the moon, and one of the first to explain the principles of how a telescope works. He was very, very interested in great conjunctions. And in 1604, he published some of his work in a very famous book that's called De Stella Nova, where he actually mapped on the ecliptic coordinates that were marked by the signs of the zodiac. And I can see Pete with his kind of, not the zodiac, because it's going to go slightly towards astrology now. But we'll notice here that in the bottom right-hand quadrant of the zodiac, so it's split into 4 different sections. These are known as trigons. And each of the 4 trigons is supposed to represent water, fire, air, and water. Sorry, water, fire, air, and earth. Yeah, not water twice. Originally, it was thought that these conjunctions have a cycle of 960 years. We now know it to be about 2,400 years. So that is for for a conjunction's position to repeat itself after one full cycle. So again, this is Kepler's trigon. And what I've tried to do is map the various great conjunctions that have occurred since the year 1000 and move it forward about 2,400 years. And you can see it slowly makes a kind of cartwheel shape, and it cartwheels its way back to its original position. Right, so why all this astrology talk then? Well, it goes back to history. In 1583, there was a great conjunction that occurred, and people knew at the time they could map it. And it turned out that this appeared to be the final visit to the water region of the zodiac. And this sparked omens of epic proportion. So all across Europe and maybe in other parts of the world, but definitely in Europe, there were a lot of doom peddlers at the time that sparked this as potentially apocalyptic. If we cut forward 3 more years, there was no apocalypse. We're all still here, aren't we? Just about. I hope people are still listening and they're still about. I hope they've not dropped dead. And Pope Sixtus V at the time called this judicial superstition, and he declared the infamous papal bull, which was, he declared a ban on all things astrological related, basically saying that it went against all Christianity and it was judicially superstitious. So that was around the medieval times, or around the Renaissance period, I should say. The closest conjunction that has occurred in the last 1,000 years, well, for that, we actually have to go back to the days of Genghis Khan. So this was in 1226. Genghis Khan, he still had 1 year left in him, and he was invading parts of China. Francis of Assisi, the Italian saint, who, you know, is best known for his work on pets and animals, or that's his martyrdom for it. He just died, and a great conjunction had just occurred. This one was separated by just 1/14 of the diameter of the moon. So this was 3 times closer than what we'll be observing tonight, if you can. It would have been absolutely incredible to observe this with a telescope, no doubt. When we look at potential, well, how it looks through animations when we trace back the orbits, you can see that the moons of both planetary systems, they just cross over with one another. It would be extremely difficult to pick which moons belong to which system. So it would have been absolutely amazing to have witnessed that. Now, here's a question. What is it that the wise men saw? As probably one of the most famous stories known to humankind is the Nativity. And we're around Christmas, and I'm sure that people are very interested in the Christmas story. And what was the Star of Bethlehem? We're going to go over some potential candidates for what it was. But to get there in the first place, I think it's important to set the scene for the Nativity. So effectively, Joseph and Mary of Nazareth were told by Angel Gabriel, there's a figure of him here, that they will receive the Son of God. And that Mary and Joseph had to go to Bethlehem to pay their taxes, something that we all know far too well in almost every walk of life around the world now. And then there is the famous story that they went to Bethlehem, and sadly there was no room at any of the inns. So they had to settle in a manger for the night. And that night is when Jesus Christ was born. And like in any story, there is a meanwhile to it. So the meanwhile is that King Herod, who was the king of basically all of Judea and the Middle East, he had asked the wise men to try and find this Messiah that he'd heard about. And the wise men realized that there was a star or some huge celestial body that will guide them to Jesus Christ. And that's where they gave their gifts of gold, frankincense, and myrrh. And they were supposed to return to King Herod with this news, but they didn't. They carried on their way to Egypt. So Herod was furious, and he sent for all the infants in Judea to be slayed in an attempt to basically get rid of Jesus Christ. Joseph and Mary knew about this danger, and they fled to Egypt, and Jesus Christ reportedly was there for the next 2 years. So hopefully that sets the scene in a biblical sense as to what happened in the Nativity. I apologize, it's a very shortened version of it, but this is just to get a kind of version of the major things that happened. So we want to ask ourselves, what was the Star of Bethlehem then? The first place of evidence that would only be fair to look at is, well, what does the Bible say? You know, it's a Christian story. We should look at the Bible to see what comes up in those passages. So the first one is from Matthew 2, chapter 1. This is where he says that Jesus was born in Bethlehem in the days of Herod the king, and there came 3 wise men from the east of Jerusalem. So we can't help but put our detective hats on and try and piece together, well, what can we learn from that? Well, of course, it says Jesus was born. It also says that the visit of the wise men happened sometime between 39 and 4 BC. How do we know that? Well, we know that because that was the reign of King Herod. Herod died in 4 BC, so it must have been at some time around there. The second one basically says that they saw the star from the east. It went before them and it stood over where the young child was. So one strange thing about this story is if it was so bright, well, very few people saw the star. And it tells us that the star kind of appeared twice. It guided the wise men to follow it, then kind of went missing, and then guided them from Jerusalem to Bethlehem, where Jesus was born. And then there is one other passage which is a little bit hidden. This was retracted from the sort of King James Bibles of modern day. And it says how there was an undescribably great star that shone amongst these stars and dimmed them so that they no longer shone. So this is a kind of star that would have to be incredibly bright for it to actually dim the other stars around it. So something that's comparable with the full moon. A strange thing is, if it was so bright then, why didn't Herod see it? And why didn't the rest of Jerusalem see it? I'd like this to be part of the Q&A later as well. If anyone has any questions or would like to say stuff about this story, I'm very interested to hear it. So let's briefly go on to the wise men. Okay, so they were known as the Magi in Greek, which translates to wise men. And they were probably priests of Zoroastrianism. They were involved in a lot of astrology. They were very skilled astronomers, though, as well. And they were in the business of interpreting dreams. It's known that they came from the East. Certain scriptures of this put them in Arabia, Persia, or Babylonia. So around what would be in modern day kind of Saudi Arabia or the Yemen. And they were following, basically they were looking for a king of the Jews. They were first referred to as "we three kings" in the 6th century. They were just known as wise men at the time. And it's interesting, there weren't necessarily 3 of them. It's just that there were 3 gifts. So it figures that, you know, they were carrying 1 each. So when did all this occur? So we know that King Herod died in 4 BC. Christ must have been born before this. There's an ancient inscription that was found in Ankara in Turkey around 50 years ago. It's a tax document. That's amazing. Taxes can help us. It's from around 8 BC, and it marks the time when the Roman Emperor Caesar Augustus declared that the world should be taxed. Everybody in the world needs to pay their taxes. So you can thank Mr. Augustus for the reason why your council taxes are so high then this year. Now, what we're looking at is we're trying to put a little kind of timeline on Jesus's birth, right? And it's kind of showing us here that the most likely birth date is somewhere between 5 and 7 BC. But wait, Jesus was born 5 years before Christ. That doesn't make any sense. Like, how does that work? It turns out that around 500 years after Jesus's birth, there was a Roman monk called Dionysius. And he tried to make a calendar which went from the first year that Rome was born. And then he counted all the various successions of Roman emperors, counted them up, and then put a system based on that. And it was a cracking idea. It was a really good idea. But unfortunately, he forgot two major things. The first one was he forgot the year 0, so that accounts for one. But then Caesar Augustus, the taxman, well, he was known as Emperor Octavio for 4 years. So Dionysius forgot to put this into his calculations. It's what is known now as Exegesis 5-year error. So it kind of puts us, at least roughly speaking, the timeline when Jesus might be born. Christmas Day, December the 25th, we all celebrate it in the Western world. I know in various Latin cultures that the 6th of January, Reyes Magos, is well celebrated, but it's kind of recognized December the 25th as well. So it turns out that this day was chosen because it was a pagan festival to celebrate El Sol Invictus. And that was the undefeated sun to celebrate the winter solstice, which is today, as just coincidentally. The Western Church wanted to change all this, but the Western Christians wouldn't have it. So they kind of merged the two festivals together. And that's why Christmas Day is celebrated on the 25th of December. People that may know the Christmas Carol, When Shepherds Watch Their Flock by Night, well, if it was December, there'd be frost on the field in Bethlehem as well. So it's very unlikely that shepherds would be watching the sheep in the field. So flocks are usually not in the field between that time. They usually are between March and November, and the lambing season occurs between March and April. So let's just bear that in mind when we go on to what the star might have been. So we know that it went before and it stood over. This means it can't be something like a shooting star because it wasn't a long enough event. Sorry, shooting stars and fireballs, they burn out so quickly. Couldn't be that event. So what about comets? That's another possibility. So there are many catalogues for comets and you can trace them back. And there are two that occur around that timeline of, let's say 10 BC to the year 0. Yeah, so we can whittle it down to possibly two, one in 5 BC that occurred in Capricorn, and another one in 4 BC, which is probably more like when Herod died. And this was actually known as this is actually referred to as a possible nova star. So that's not a comet, that is actually a super hot old star called a white dwarf. And these things are so hot that when they're in systems with other stars known as red giants, they feed off that star and they're so hot that they re-radiate that light and they appear as new stars. So even though it's got the term nova, novas are not young stars, they just appear exceedingly bright. Venus, it's been questioned quite often, and it can appear up to 15 times brighter than the brightest star in the sky. But for Venus to be, the candidate, the wise men were very skilled astronomers. It's unlikely that the morning star of Venus would have caught them out. But who knows? So planetary conjunctions, Venus and Jupiter, there were 2 conjunctions of them near the birth of Christ. The first one is in 3 BC, which was observed in the Leo constellation. But this is in the east. And as we know, the Star of Bethlehem was seen by the wise men in the west. So it might be in the wrong direction. There was another one that occurred in 2 BC as well, close to the western horizon, but it's likely that this was a little bit later than Christ's birth. So, okay, there's one astronomical possibility remaining, and that was the triple conjuncture of 7 BC. So the dates for this are set around May, September, and December. And it occurred in the constellation of Pisces, which is in the west. So that's another tick for us. So one possible sequence of events is that the wise men saw this. They saw the first conjunction in May. They followed that star to the west, and then they saw it again once they got to Jerusalem, because they had to travel 550 miles across the Arabian desert to get there. It would have taken them around 4 months to get there. They saw the conjunction occur again, only this time in the south. They followed that star, and lo and behold, it took them to the stable. So under that hypothesis, it might be seen that Jesus was born around October in 7 BC. There are other possibilities. There are possibilities that this was divine creation. It was an act of God that doesn't require any scientific understanding at all. That is to be completely respected. And all we're merely doing here is tying together astronomical events that, you know, occurred around that timeline. So I'd love to talk about that later. So let's recap. Basically, a conjunction is when Jupiter and Saturn appear very close in the sky. They occur every 20 years or so. Tonight, they're going to appear so close that they're within 1/10 of a degree of each other, about 1/5 the moon's diameter. And this is the closest we've ever seen it in 400 years or so. And for youngsters out there, you're in luck, because a similar one's going to occur in 2080. Excellent. Now, before I get on to this next section, has anyone got any good skies? We're shaking our heads. I'm willing to be, I hope to be interrupted. I really do. I'm really hoping for someone to say, I've got to stop you there. There's a patch in the sky. So until we get that, I'm afraid I'm just going to carry on wattling on with this. So let's go on to, and Jordan and Pete can hopefully help me here with the idea of when can we observe this, how can we observe it, and what can we observe it with. So the time of closest passage is going to happen in about 72 minutes. So that's 6:37 Greenwich Mean Time. But Jupiter and Saturn are moving, well, quite slowly relative to each other in the sky. If you want an idea for that, since early November, they've been closing in by about 2 moon diameters every 5 days. What this means is it's been observable as 2 very close planets since, you know, late this year, and they'll continue to appear close right into 2021. It's winter conditions in the Northern Hemisphere, unfortunately. As it's shown tonight, it's often cloudy, rainy, or it's just too cold to get out there. You can understand that. It's also good, though, because there's many nights that we can observe it. Actually observing this thing very close to, you know, that point of conjunction, well, it's going to be observable within half a moon diameter. It has been since the 19th and will continue to for the next 2 nights. So if we get a clear night, you know, coming up soon, we will get the opportunity to observe it. It's just tonight's live observing might be a little too difficult. So this is an animation that was shared to me by Matthew Bate at Exeter University. Professor Matthew Bate has kindly showed us the paths of Jupiter and Saturn across the sky as observed from Exeter in the United Kingdom at 5 p.m. And what we can see is that by mid-January from the UK, around 5 p.m, those 2 planets will have dipped below the horizon. So they won't be observable beyond January. However, perhaps in other parts of the world, there will be. So depending on where you live, you might get an extended time period to observe the Great Conjunction. Another question is, where can we observe it then? Which parts of the world? Jupiter and Saturn are going to be 30 degrees east of the sun. That's quite close to the sun. It's why we can only really observe it for a short amount of time after sunset before it finally sets, before Jupiter and Saturn finally set in the sky as well. This is great if you've got kids. There's no late nights to deal with. There's no like other astronomical events where you have to get kids out of bed at 3 a.m. This one's at least in sociable hours for families. If you're in the Northern Hemisphere, you can observe it in the southwest. And if you're in the south, in the Southern Hemisphere, it's more in a westerly direction. It is near the horizon, though, as we mentioned before. So it's only observable for an hour or two after sunset. If you happen to be listening or viewing this from Greenland or above, unfortunately, you're only going to get it about 5 degrees above the horizon. So it might be extremely difficult to see the further north, or the closer you get to the poles on either side of the world. If we put that into perspective, what we've got is, if you live on the equator, then you're going to see it at its highest compared to anywhere else in the world. So Jupiter and Saturn will be around 25 degrees above the horizon. As you venture further north or further south, where Jupiter and Saturn emerge is going to get lower and lower in the horizon. So where we are in the UK, it emerges around 10 degrees above the horizon, at the moment around 5 p.m, and it's set by about 6 p.m. as well. I can see Jacko is double checking. Anything? Oh, unlucky. Everybody blow on the clouds.
Yeah, just interrupt very slightly. The Canary Islands, Slew at the Canary Islands are going to be doing a live broadcast at 7:15, apparently still above the horizon at Tide Observatory at 7:15. So what I'll do, I'll leave this stream open and I'll rebroadcast their live broadcast, if you like. So there is a possibility that we may see something. So if you just check back here at about 7:15, I'll leave this streaming so that if it does happen, you can see it.
That would be great. We need every opportunity we can get to observe this thing. So thanks, Pete, for doing that. Okay, so might need a little help with this one because I am not much of a, what you might call a swinging a telescope kind of observer. You know, my day-to-day job, when I get the chance and I get telescope proposals accepted, is I have the divine luxury of sitting in an observing room while lots of very complex computers and robotic systems take the observations for you. So when it comes to viewing the night sky, I might know a thing or two, but let's work together as a team, explaining how we can observe this thing. So by eye, now I've seen this over the town I'm in, where I live in Nantwich in Cheshire in the UK, that even in light polluted towns and cities, you can observe this thing with the naked eye. So, you know, not through clouds, but through the naked eye if it's clear. You need to look low in the evening sky, somewhere towards the south or southwest. It helps if there's not buildings in the way though. So try and get somewhere where there's a clear horizon. You have been spotting them getting closer and closer if you've been observing them through November and December. And depending on where you live, in terms of, you know, what latitude point you live on the globe, you also see them moving apart in the next few weeks as well. Jupiter's going to appear slightly brighter. If you've got good eyesight, then you might be able to resolve that kind of intensity. Unfortunately, you're not going to see anything much apart from that. You're not going to see any rings or bands or moons or particular features, but you will be able to see one brighter than the other, which will help you see which one is which. What about if you just have a camera phone? It turns out it is possible to take a photo of it. We'd all love to have these fancy, you know, very nice DSLR cameras mounted to 12-inch Dobsonian telescopes, and certain people have them, and you know it's a very worthy hobby to pursue. But what if you just have a camera phone? Yeah, you can observe it, And it's great if you just want a snapshot of it. You can show your friends, you can show your family in a kind of I was the kind of situation. Jupiter will look brighter as well, so you'll be able to explain that one to your friends and family too. A few tips if you're going to do this. Try and have the phone balanced. If you've got any kind of wobble on your phone, it just really affects the exposure. And what you get is just a very scattered light image. You won't be able to resolve the planets. Definitely not. If your phone allows you to, try and set the exposure time to a few seconds. Of course, it's a trial and error process as well, so play around with it. I found setting the resolution to a low setting helps, but again, depends on your phone, I suppose. One thing's for sure, make sure your flash is turned off. If your flash is on, well, it's no surprise you're going to just see a big flash. So, and do your best to avoid artificial light. I know if you live in a major city, you can't tell your council to turn the lights off, but just do your best to try and get it between street lights at least. So I'm just showing a picture of something that me and my son took about a week ago from Barony Park in Nantwich with a camera phone. And this is between two street lights as well. So you can get an image of it, and some of them look all right as well. That one's not going to win any prizes, I'm aware of that. But some of you might win some prizes later, who knows? When it comes to binoculars are really nice because they're relatively inexpensive and they're very portable as well. You can carry them with you, and if you get the opportunity to use them, you can just look through them. When you're looking at the types of binoculars, they're usually characterized by two numbers. It's like a multiplication of two numbers. The first number describes the magnification that you'll get, and the second number usually tells you something about how large is the lens of the main part of the binocular. Generally speaking, you've got 7 times 50, 8 times 50, and 10 times 50. They can vary as well. Those kind of binoculars, if you happen to be, are you really going to be at a music festival in 2020? Sorry. But if you happen to be at one in the near future, let's hope so. Well, if you stood at the back of a crowd, you'll see your favorite musician a lot easier with those binoculars. And it's great for watching birds and wildlife. And it's also really useful for observing moons, comets, and star clusters as well. So for an example, if you got 7 times 50, you'll probably get the Galilean moons. 10 times 50, you might start resolving Saturn's rings. A lot of it depends on how close Saturn is to us at the time when you observe it. Now, at a real push, if you have something at 20 times 80, you might get Jupiter's bands, but you'd be very lucky. Really, you might want to push that magnification closer to 30 or 50 to actually be in with a shout of observing something on the surface of Jupiter. Is that agreeable, Jordan and Pete?
I think you'd be pushing it 10 by 50 to see Saturn rings, to be honest. I think you'll detect that Saturn is oval, egg-shaped, but whether you can discern that those are rings, I think you'd actually be pushing it. Binocular-wise, I have hinted at bands at 2080, but again, you are pushing it a little bit.
Sure. So we're kind of saying they can be very cheap. You know, if we put this into pounds sterling, Pete, if we can just help the viewers, we don't want to name brands, so to speak, but we 50 quid.
Yeah. I mean, if you spend on 2080s, you can mention brands on here. It doesn't matter. It's Astro Radio. We're not the BBC. You can say what you like. One brand I do use myself is Celestron, and I've got some 70. I think a 15 by 75s, and they're very nice. And they were about 80 quid. 10 by 50s, again, I don't know on brands with that, but you're looking about 50 quid, yeah.
Okay. Brilliant. If you're holding them for a long time, they can be a bit tricky to hold. That's why tripods are quite useful to invest in.
Well, a better thing to invest in if you're going to use binoculars is a thing called a parallelogram. And this fits onto the top of a camera tripod and it moves so that the binoculars are always at the right height for you and you can move them up and down. And with a tripod, you're kind of limited a little bit. But with a parallelogram, it's very easy to move round, up, down, and they always kind of stay at the same height. And you can lower the parallelogram down for people that are shorter and so on. So I wouldn't go with a tripod. I'd go with a parallelogram. And again, you're looking at about £110, I think, is an average price for a good parallelogram. But the best thing to do with that is to read Steve Tonkin. He's the binocular guy. He's the expert, the UK's leading authority on binoculars. Just get one of his paperback books off Amazon, and everything you need to know about binoculars is in there.
Brilliant. Okay. They can feel a bit heavy if you're holding them for a while, I suppose. And well, I have put the capturing images is not practical, but I'm quite sure that there are potential ways to mount a camera to a set of binoculars.
I've never done that.
No, I didn't think so either. I just kind of figured perhaps common sense is it's not.
Mary McIntyre just said you can always use an upside down sweeping brush until your mount arrives.
Yeah, I should say the image that me and my son took.
Yeah.
We don't have a tripod. All we had was a camera phone and a shoebox. So
there you go.
You know, it's very how can we put it? Use whatever you've got.
Yeah. Yeah.
It can work. So with telescopes, good quality small telescope with a kind of magnification of around 25 to 60, you'll be able to observe Jupiter's brightest moons, the Galilean moons, Saturn's rings and its largest moon.
Mm-hmm.
You might be able to observe the disk of Jupiter and resolve perhaps some of the bands, but I guess it depends on observing conditions and the distance the planets are away from Earth when you observe it. So many modern telescopes have attachments for digital cameras. These are great for photography, or what we call astrophotography, and the prices and qualities vary enormously. So I suppose one of the best things to do is just get out and do some research. Pete and Jordan and many others that I've met at this station, they are really expert at providing advice for what to get. So I'll leave it for them to chat with you if you're interested. You actually don't want very high magnification for the conjunction. The reason for that is you actually want to observe Jupiter and Saturn at the same time. So this is what's called the field of view. It's the kind of region that you're observing around. So it's usually given by an angle. So if you imagine Jupiter and Saturn at the moment, 1/10 of a degree, ideally it's something between 1/2 a degree and 1 degree field of view would be quite useful to have. So at 1 degree separation, 50 times the magnitude, you're probably going to get Saturn's rings, Galilean moons, a few Saturnian moons. If the conjunction isn't observable, there's plenty of other things in the sky to observe too. So, you know, features of the moon are just a brilliant starting point for astronomy. If you swing your telescope or whatever observing equipment you have at the moon, you can really start resolving some awesome features of it. And star clusters and perhaps some of the bright galaxies you'll be able to see as well. I've got an embarrassing slide coming up right now that says live observing. What isn't quite as embarrassing though is we've got some really nice artwork from the Year 5 students of Nantwich Primary Academy. So they've worked really hard in the past couple of weeks in the run up to Christmas and this event to share their artwork with us. So yeah, I'm sure they'll be very happy to get a mention out on here, and they've done some really good work. So if we can't do some live observing, which is a shame, but it's the way it is, and we'll have plenty of other nights to observe this conjunction as well. I suppose it'd be a good time to jump over to Jacko.
Hi, Alex.
How are you?
I'm fine. A bit cold in here.
Yeah, sorry to keep you there.
So yeah, it's not looking good outside, but I can say a little bit about the telescope here and a bit about Saturn and Jupiter, what we've learned about them.
Please do.
Yeah, right. Those of you viewing, you can see behind me part of the large refractor, the great refractor of Keele, because it's so great that it doesn't all fit in the picture. It's more than 4 meters long, and it's got an aperture of 31 centimeters, 12-inch. So we're extremely lucky to have this telescope here, and what we want is that the public also enjoys it. So non-COVID times, we're open to the public to come and look through it, and it's really magnificent. And one of the things I like about being an astronomer is that when you look at the Great Conjuncture with the naked eye, you can see it. You can see Jupiter, you can see Saturn. We have known Jupiter and Saturn since we had eyes. But then when you're using a telescope, you see things that you could never have seen without. And this is great about the job of an astronomy, that we're staring into the universe and we're seeing things you cannot see in any other way. So to share that with the public is also really amazing. And even though when you look through a telescope like that, even look through the great refractor of Keele, the pictures don't look as good as we are spoiled now looking at pictures from the Hubble Space Telescope or from spacecraft like Juno and Cassini. But still, seeing it with your own eyes, directly looking at the object, it's amazing. So those of you viewing, there's a picture by Paul Doherty, who made amazing drawings, looking through the telescope. So the amount of detail that you can see through a telescope, if you're patient and you've got a good winter night of cold air, is really amazing. You can see the Cassini division, of course, discovered by Cassini. And of course, some of its moons, especially Titan of Saturn. And obviously, if you look at Jupiter, you see, well, sometimes you can see the great red spot, but it happens to be always at the other side, apparently. It has faded, but it's still there after all these centuries. And this is really an amazing thing in our solar system, which I think we know now of so many other planets, and other people will talk about that, but our own solar system is the best of all, I think. So I'm going to just share my screen, but I'm going to do a lot of talking, but only for a couple of minutes, don't worry. So let's see, and there we are. So the telescope at Keele, the Great Refractor, is actually also very old. It dates to 1874. And at that time, we knew very little about what we saw in the universe. Not much more than what you can see with the naked eye, to be honest. We didn't know why stars shine, for instance. I mean, come on. So looking through those telescopes at the planets too, photography was in its infancy, and you could take a picture of the moon, that was about it. So you had to make drawings, and that's why there were all these stories about Martians, because people just were filling in the gaps when they made a drawing and drew rectilinear structures when it was just a collection of dots. So observations of the planets, of course, were a bit limited until actually first the spacecraft flew there, and then next we got better telescopes in orbit around Earth and also from the ground, and special techniques to get very, very sharp images. And if you see what amateurs are able to do nowadays, it's amazing. They get better images than many images taken at large observatories. The telescope here is also of historical value because it used to carry a camera, which was used in 1919 to look at the solar eclipse, which confirmed one of the predictions of Albert Einstein's general relativity theory, namely that matter bends space and light will therefore go around a curve. So that's quite nice to have that here. So just a few things that I found particularly interesting about Jupiter and Saturn. First of all, Jupiter is big, right? But you only realize how big it is when you compare it to the Earth. The Earth is a tenth. Now, a tenth, okay, what does it mean? If you see them side by side, then you really realize what a tenth is. It's tiny. And actually, the Earth is smaller than the red spot. That's just amazing. An entire hurricane the size of Earth. So that's one of the things. The other thing is the fact that Jupiter is so big. First of all, it's because it's mostly gas. It's a ball of gas. There's a lot of gas around in the universe, hydrogen and helium. It's mostly hydrogen and helium, a little bit of else. Pretty much what the sun is made of. It's just not big enough. If it were bigger, it would ignite and be a star. So it's sort of in between, like what you typically think of as a planet and a star. It's just not ignited. It's not big enough. But the pressure inside is extremely high. And it's so high that the hydrogen actually becomes metallic. And so the electrons can move around and you can generate magnetic fields. And Jupiter has a very strong magnetic field. And that creates aurorae. And the pictures of the aurora of Jupiter are spectacular. If you would be there to see them, just like you could see the northern lights from Earth, it would be quite amazing. Of course, the best pictures of Jupiter are taken with spacecraft that you sent there. And Juno has taken pictures of the poles of Jupiter, which obviously you can't see from the Earth because you're always looking at equatorial bands. But seeing it from above, it's a view we've never seen before. And what it looks like is lots of whirlpools. And immediately, probably I'm not the only one, you think of a Van Gogh painting, The Starry Night, with all these whirling things in the sky, as if he knew what the top of Jupiter looked like. Now, perhaps more interesting than the planets actually are their moons. And of the Galilean moons, two in particular are interesting. One is Io, which is closest to Jupiter, and it's so close that the tidal effects that we also experience on Earth and the Earth-Moon system, we have the tides, the water rises a little bit up and down. Now, the tides in Io are so strong that the inside is molten, and it's so boiling hot that actually produces volcanism on the surface. And the surface is covered with sulfuric fields. It must be smelly. The next one out of the Galilean moons is Europa, which is also close enough so that the inside is kept warm, but otherwise it's covered with ice. So you've got these ice flows, and they're all cracked and have reformed. So it's very clear, obviously, that underneath there's something that's much more liquid. And there's almost certainly a liquid ocean or some kind of brine underneath. So people already thought like, oh, this is interesting. If there's water, there might be life. But actually, Europa is probably not the best place to look. So let's go to Saturn. Now, Saturn, of course, is everyone's favorite because of the rings. And yes, it might be difficult to see the rings in a binocular, but you only need a small telescope to see the rings. And those telescopes are already vastly better than what Galileo had. And that's why he made the mistake of first thinking that he was looking at moons. Now, the pictures we have now of the ring system are really spectacular because you see so many rings. Jordan already mentioned it. And those rings are created from the tidal destruction of one of the moons. And indeed, a few 100 million years from now, that material will have gone. But because all 4 giant planets in the solar system have got rings, we know that this is a frequently occurring event. And so in a few 100 million years, perhaps it's Neptune that has the greatest system of rings. And then a few 100 million years later, it's Jupiter. Now, these things happen all the time. And there's lots of interesting things happening, the dynamics in these rings. Now, again, some of the most interesting things in the Saturn system are its moons. And Enceladus is one of them. It's quite small. It's again covered with ice because it's extremely cold. Saturn is even further away from the sun than Jupiter is. But again, inside it's hot enough so that there's steam bursting through cracks in the surface out into space, and we can see that. We can actually study the composition of that material, and there's lots of interesting stuff in there that's organic material. Don't think immediately about life, biotic material, but organics nonetheless. And the interesting thing in Enceladus is that probably the water is sitting on a bedrock, and that's very interesting for possible life forms. So if we have to choose Europa or Enceladus, we should go to Enceladus. But to finish, my favorite is Titan, because Titan is not only the second largest moon in the solar system, It's actually a mini planet. It just happens to orbit Saturn. It's got an atmosphere made of nitrogen, like ours. Okay, it's very cold, so there's no water. It's all frozen out. There's no oxygen, obviously. There's methane and ethane, and there's weather. And it's actually cloudy on Titan most of the time. Now, we complain that we can't see the Great Conjuncture from England today, but on Titan, it's almost always cloudy. And sometimes it rains. Not water, but so it gets quite sticky, probably quite muddy into your wellies if you go and walk around there. But if there's one place in the solar system that I would like to go if they offer me a ride on a spacecraft, then it's Titan, definitely. So I did send a little video to Alex if you want to play it. Yesterday I did see the Great Conjuncture from home. I had a small telescope, just a Smith Cassegrain, 20 centimeter, and I put my DSLR at the back, and lo and behold, it was clear just before sunset, just after sunset, just before Saturn and Jupiter set, and I just managed to take a couple of pictures, but then the clouds moved in. So I was lucky, but as Alex says, there are a couple of more days when you can see it, and for England, people in England, Thursday is looking quite good. Elsewhere in the world, you might be more lucky before then. So yeah, Alex, I'll hand over to you back.
Superb. Thank you for that, Jacko. It's just really informative for us all to learn a bit more about the moons. So Titan's your favourite?
Yes, Titan, definitely, because it is like a planet. So you can really imagine that with the atmosphere, the weather, you've got a lot of the things that we see on Earth. Whether there's life out there, of course, that's a different matter. It is extremely cold, so it will be very sluggish life, probably.
Yeah.
So we haven't found any life in the solar system yet, but many of the conditions are there for life, and this is already interesting enough. Now, it might be quite tricky to actually start up life, but studying the different conditions which could possibly be conducive to life it's very interesting, and it's just on our doorstep. I mean, it's
Can you tell us how we distinguish between a moon and a planet, then?
Yes, so to some extent, as I said, like Titan, if it would be orbiting the sun on its own, we would call it a planet. It's actually larger than Mercury, which is a planet, right? So it matters a bit where it is, what it's doing. And Titan happens to orbit Saturn, which is a massive planet. And so clearly the center of mass, so where the gravitational center is inside Saturn. And so therefore we call Titan a moon. But many of the moons, so Jordan, I think, mentioned that there are over 120 moons between Jupiter and Saturn. Some of those are large, and they may have formed as planets would have formed, just in the material swirling around the proto-Saturn and the proto-Jupiter. But other bits are quite small, and have probably been captured. And actually, that reminds me of when Jupiter caught a comet, Schumacher-Levy, in the 1990s. So Jupiter is an excellent comet catcher in that sense. So it gravitationally pulled it, and the comet escaped once, but the second time he couldn't. And it got stretched out and tightly disrupted into fragments, and one after the other fell into the cloud deck of Jupiter. And I had my telescope already, and I saw those black spots in the clouds, and that stayed for a couple of weeks or so. And then
Jacko,
yeah.
Will you be able to stick around and answer some questions to do with Jupiter and Saturn's moons?
So I need to go in a couple of minutes, because
Absolutely.
we only have one car to share, and the car needs to go home.
That was me thinking you lived in the observatory, Jacko.
No. Well, I'll be online in another 40 minutes then. Yeah.
That's okay. Pete, I suppose this would be a good time to explain that while the radio station, while this edit will cut out at part 6, we can stick around on YouTube for all kinds of Q&A sessions.
It's good. It's there as long as you want it.
Super.
Can I just share my screen a little bit?
Absolutely.
I just want to show a few images that I took last night. Also, just can you see that okay? Does it come up with the logo?
The poster?
Yeah.
Perfect.
That picture of Jupiter there is from Juno. Now, I don't know if you're aware, but all the Juno data, the raw data, not the process data, is available online, free of charge, to process for yourself. And I did a guide in Sky at Night magazine, which I'll if people want to email me and want that information, if they email me, I'll give you the link to, so you can download the guide on how to process your own Jupiter images live from Juno. So that's an image I process live from Juno. So you can have a look at Jupiter close up with, and process spacecraft data. And I always say, when I was a kid, I can just about remember that. It would have been like Harry Potter stuff to be able to process your own data from a space probe. But you can also process all the Saturn and Cassini data. Parker Solar Probe, New Horizons is coming online. All the raw data is there for you to play with. So, for people that are interested in looking at Jupiter, and like you say, you look at that and it's like a painting, isn't it, rather than a surface. But last night I took a picture of the conjunction. You could just see Jupiter and Saturn there together. I managed to get a little gap in the cloud last night, not very long, but I had about 5 minutes gap. So that was from a field just above our village. That's a little bit closer up, but I don't know if you can see on that, but there's a strange line there and we can't quite work out what it is. I thought it was a line on my screen, but it isn't. It was on that photo. Some say it's a bird. There's all sorts of ideas. It's definitely not a UFO, but well, it could be a UFO. It's unidentified. So there we go. And that's another close-up of the picture I took last night. Another zooming in a little bit, and then I put my 4-inch telescope onto the mount and managed to photograph that one of Jupiter and Saturn together. That was that was the night before, and that was last night. So they were a little bit closer, as you can see. And this is a photograph from Mary, who's in the Zoom at the moment. That's from Mary. Mary's an excellent astrophotographer and excellent outreach person. So if you ever need any information, Mary's a go-to person for that. And also, this is from Jonathan Harty up in North Wales from last night as well. So that's a picture from that they did, and then they did. Tracy and Jonathan did this beautiful picture showing where the different moons were as they did that. So it's just a little bit there, just things that were done.
With this final image, sorry, Pete. With this final image, a few people contacted me earlier today to ask what the 5th Galilean moon was in their image.
It's a star.
It is, isn't it?
It's a star, yeah. So a faint star in the field of view. Yeah, to be honest, when I first saw it, I looked at that and thought, well, what's that? And then I realised, it's a star. So
I've had that many times where I've taken an image of the planets and I see extra dots somewhere. I'm thinking, I didn't think there were moons there.
Yeah.
There's just a bit extra stars in the background.
Yeah, but there we go. So that's just a little bit of stuff from yesterday, but there's obviously going to be far, far better pictures in your competition.
Yeah, thanks, Pete. And speaking of competition, better explain what this is. So from now until 6:20, I'm going to share a couple of interviews that I had earlier, in the weekend, with some Keele astronomers. We're going to listen, first of all, to Becky Arnold, who just joined us at Keele a couple of months ago. And she wants to tell us about the life of an astronomer, what she does in her day-to-day, and effectively how 2020 has panned out for the world of astronomy. As you're watching this interview, I'm going to have a slideshow playing by the side of it. So listeners obviously won't be able to see this. You'll be able to hear the interview. People viewing this on Zoom or on YouTube, have a look through the images, and there's going to be a link to Google Forms. If you click on that Google Forms, you get the opportunity to vote for which image is your favorite. Just for a bit of fun, we're going to have this as a UK competition and an overseas competition. The winners of these are going to be the recipients of, what was it, Pete?
It was a book, a 2021 Night Sky Guide book by Nigel Hembest, and I'll throw in one of my mugs, one of my Milky Way mugs from my Milky Way photography earlier on the air. But I was sorry, I won't be able to post these out till after Christmas. But if you get whoever wins, if I get their address, I'll make sure it gets posted out.
Yeah. Well, the winner obviously will get in contact and find out where to pass on the prize to. So
yeah.
Okay, so without further ado, let's see what Becky Arnold had to say when I got in touch with her. So on the line right now, we've got Becky Arnold, who's just joined us at Keele University a couple of months ago. Becky is an expert in the dynamics and evolution of star clusters. She received a PhD at Sheffield University and then spent some years in the US studying there. So she's just joined us at Keele recently. Becky, how are you?
Yeah, I'm doing okay. Thank you very much, Alex.
How are you settling into life at Keele?
It's good. It is nice to be back on UK soil, especially given the current times. It's nice to be home. And also Keele group's really friendly. So I'm enjoying getting to know people and start collaborations here. Started doing some work on, because my research particularly works on statistical methods and how to apply those, particularly to astrophysics. I started a collaboration with Johannes Freenson in the drug study department, looking at trying to study how different we can apply the sort of statistics we use in astronomy to study the properties of different molecules and how those could be, how to study whether they would be likely to be useful for medicinal properties. So I'm really enjoying applying these statistical methods to different problems. And I've only been here a couple of months, but I really hope I get to do a lot more of that sort of thing, because I love the sort of intersection between different disciplines and how we can learn so much from each other.
That's fascinating, because there might be a few listeners and viewers out there that are thinking, well, hang on, I thought that Becky was an astrophysicist and she's talking about drug companies. But in reality, science is quite an interdisciplinary thing to study, isn't it? So it's fantastic that we can take lessons from the world of drug manufacturing and apply it to statistical methods of star clusters. I find that quite fascinating, actually.
Yeah, I think so many different disciplines I always love talking to researchers from different fields, because somebody starts talking about their research and an entire different field of problems and solutions and different things we thought we knew about, but we don't, just completely just explodes and opens up like this fractal. And I think, yeah, the more different disciplines can talk to each other, the more we can learn from each other, and problems that may have already been solved in a completely different context can be applied to solve different problems, to study astrophysics or to study the medicinal properties of different molecules. I think, yeah, that's something that I've started to do more of, and I really hope to do more of in the future, because I love astrophysics, but my biggest problem when picking what field to go into was I just find all of it fascinating. And astrophysics are the best. It's totally the best. Let's be real. But there's loads of fascinating stuff too.
No bias here, obviously, you know.
Listen, you can't. Every human in the history of humanity has looked up at the sky in wonder. It's got to be the best.
So could you give us an idea or an example of what one of your challenges might be then these days? So you're applying different techniques from different fields to what you study. Could you give us an idea of one of the things that you study?
Yeah, so my research is mostly on computer simulations, because you talk about sort of central challenges. Is observations are great and they tell us a lot about the universe, but if I want to study how a star cluster evolves, that takes millions and millions of years to happen. So even if you have the most perfect observations ever, if some observers go out and observe a star cluster and can tell us everything about it in perfect detail, that's still only one snapshot of its millions of years of evolution. So I use simulations to try and study how that cluster or any cluster may have evolved over time to get to that point, how it may evolve in the future, and what that can tell us about the process of star formation itself.
Excellent. Yeah. So I guess the way that my own work would tie into yours is I would roughly describe myself as a observational astronomer. So I like to go to telescopes, collect data, try to measure the properties of these stars. Now, it sounds like what you do, Becky, is you create some kind of framework to interpret what those observations are. And this is the nice thing of astrophysics, isn't it? It's when you get that kind of marriage between ideas and concepts on one hand and actual real tangible data on the other.
Yeah, absolutely.
When the two combine, it makes a very satisfying, all-rounded picture of what we can learn.
Yeah, because we have the data, and what does this tell us? What does this tell us about the universe and how it works? And you can't just have models and you can't just have data. You've got to put them together to get answers.
That's right, yeah. I remember someone telling me recently, ideas change, but data is permanent.
Yeah.
But that can be good on one hand and bad on the other, can't it?
But then you can get fascinating stuff like human biases, and the different, or mechanical biases as well, can influence that. I forget what it was. I think it was measuring, God, I know this, but I'm forgetting, measuring some fundamental constant of the universe. And the initial observation was just off, but the uncertainties on it, as people did subsequent measurements, sort of were close to that. And as then more and more measurements came, we came close to the true value over time. But because people thought we knew roughly what the answer was, sometimes that can bias your result, even with the absolute best of intentions. So I think, yeah, data is permanent, but it's also humans looking at it as well, which can sometimes be a bit of a problem. Would you agree with that? That sometimes,
I think that's a great answer to it, really. Yeah.
Especially when people have their favorite model or something, that this is what I think is the truth, and then they've got some data. Sometimes, well, that's why we have peer reviewing papers, so that if somebody is interpreting a data in a way that is favorable to their favorite model of what they think is true, that hopefully then peer review goes, well, you haven't considered that maybe this, and this, which hopefully makes for good science overall.
Exactly. Now, I'm just thinking in terms of youngsters out there that are watching this. I remember when I was at school, it's becoming an increasingly long time ago, but I do roughly remember at school, that certain science topics that we were taught, you almost felt that you were at the edge of knowledge then, as you're being told that this is how it is. This is how the world and the universe works. And one thing that I learned as you go to university and you actually start peeling back at the layers of what you've been told, it's incredible, isn't it? When you actually get into a problem and you actually realize that some of the most fundamental things that you're taught in science, well, there's nuances, there's little kind of tricky things to learn, but it's fascinating to see a little bit further into how the universe actually operates.
Yeah, absolutely. I'd say the more you look at something and the deeper you look at something, the more fascinating it becomes. Absolutely. And to get back to the interdisciplinary stuff and about other problems, like I once had an hour and a half conversation with somebody about water pipes, because they studied how to do it efficiently and how to make sure that they are produced in such a way that the water stays clean and safe and all the rest of it. And something you think, well, it's a pipe, it's a simple problem. There's so much more to it. In the simple, like with star formation, we go, oh, where there's a cloud of gas and sort of gravity pulls it down and eventually you get a star. And sort of like, well, yeah, but there's a lot of stuff in there that we don't really understand the mechanics of. And I'm really looking forward to, I'm quite young and I'm really looking forward to the future decades of science, thinking like, if I look back 50 years, the things we didn't know and what we might know in 50 years' time is so exciting.
Definitely. I mean, I've got to say, one thing that I found is almost a strange byproduct of such a tricky year that we've had is with the benefit of communication tools like the one we're talking on right now.
Mhm.
I've found it easier to share ideas and collaborate than ever before, actually, on an international scale.
Yeah, I would agree. I definitely started more collaborations in the past, 6 months than I have probably previously. I think part of that's to do with being early career and sort of starting and sort of growing connections, but I would definitely agree with you there.
Yeah. Don't worry about that. Say if you had kind of a few words of advice for anyone that was interested on getting involved in the sciences or pursuing a career in science, what words would you have for them to help them on that path?
Firstly, I would say you can do this, because I think a lot of people think, well, you have to be a genius in a lab coat with some flask with colourful smoking liquid, or you have to be Tony Stark to be a scientist. You don't. You are capable of doing this. If you're some kid in your bedroom, you can be a scientist. Believe me, you can be a scientist. Find something that you think is interesting. It doesn't have to, it can be water pipes. It doesn't matter. Just find something that you think is fascinating and just learn and talk to people that are experts in whatever you want to learn about, that have spent their lives learning about it. They love talking about this stuff. If you're a kid at home that loves something particular about galaxies, email a professor that studies that, or just say, hey, I'm really interested in this topic. Will you talk to me? Will you talk to me about this? Because people love talking about things that they are passionate about. So, and you will learn the most from them because they will tell you about all this stuff. So I would say, yeah, it's extremely intimidating, but my first advice would be just talk to people.
Yeah, it's okay to fail as well, isn't it, on the pursuit of getting something right? Because what we present, what we do, is actually the kind of tip of the iceberg, and what's underneath it is layers and layers of attempts to get it right, and sometimes quite epically failing along the way. Yeah,
and learning the most from those failures, I think, is very important, because also something in science, you may do a bunch of research looking for a certain signal and then find it's not there after years of looking into it, but then you've learned something. You've learned that thing that you thought may be the true or a signal you're looking for isn't there, and that is valuable to science too. Failure is every bit as valuable as success.
Well, that's really inspiring words, Becky, and I hope that message gets out to plenty of people out there, because we always need new scientists, don't we?
Absolutely. And and I think the world just needs more and more scientists.
Yeah, we definitely need youngsters to deal with the data that we're collecting anyway.
Yeah.
Well, that's fantastic. Thank you for taking the time to chat with us and to everybody at this event.
Thank you so much for arranging it. I know about how much work went into arranging all this stuff. So yeah, thank you for doing that.
That's no problem. I hope you enjoy it, and just wish you and your family and everyone that you love a very happy Christmas as well.
And to you as well.
Fantastic talking, Becky.
Thanks. Bye.
All right. See you in the new year. All right, everyone. Hope you enjoyed that then. Pete, I was just wondering, and Reza is from Orange County in California, and he's joined us tonight. Are you on the line, Reza?
Yes, I am. Hello, everybody.
Excellent. Right, I'll stop my sharing then. I'm still getting used to Zoom, Let me see. Could you share your screen with us there, Reza?
I can stop you sharing for... Oh, there he is. You stopped.
Oh, yeah, I just figured it. So, Reza, how are things with you?
Reza, you've muted. Oh, there he goes.
Yeah, all things are excellent here. You asked me for some photos from our members, and I sent out a call. I don't know if it looks like you didn't receive any.
I did manage to get a couple at the end. Some of them were a little last minute to squeeze into the slideshow. But I'm glad you mentioned that, because one thing we will be doing after the event is anyone that wants to bring photos, we're going to make a nice kind of historical repository of these things. So please, I would encourage everybody to get the photos through and just get out there observing. So how have you guys been in Orange County?
Well, actually, this time of the year, you know, we are close to the ocean, the Pacific Ocean, and we too get mostly clouded out here, especially when the marine layer comes in. And so, yeah, that's the situation here. There are other places across the United States that are holding star parties this evening for us, and I'll hope to be able to catch a glimpse of those, like the Lowell Observatory, as far as I know.
Yeah, no, good point. I think there's been plenty of planned star parties as well across the UK that are probably sharing the same problem with the clouds. So you're going to be observing later on, presumably, on the Pacific coast?
Yes, it's about 10:15 a.m. right now here. So we have a couple of hours to do the final touches on our telescopes and prepare things.
Oh,
awesome. I think we're still there with connection, just about.
Yeah.
Yeah, okay. I think we're good. So please do share with us anything that you find on that side of the pond as well, because we've not had the best night here with observing. We have had some reasonable nights, one or two in the past couple of weeks, but up to now through December, it's been quite overcast with clouds. Actually, it's probably just typical for December, but because we're really praying for good weather, I think that's when it really seems like there's more cloud than there really is. I mean, how has the weather been there for observing?
Well, yeah, as I told you, you know, weather isn't that good during this time of the year, but generally, so we do have clear nights more than you do. So let me tell you a little bit about this organization that I'm part of, called the Orange County Astronomers.
Please, yeah.
I don't know if we can claim we are the largest in the world, but you know, we have a little more than 700 members, and we have an observing site about 2 hours of a drive out of the city, in another city called Anza. So it's like a 7-acre land, 20 acre, I apologize. It's 20 acres land. We have built some small constructions there, pads for members to put their telescopes out. And then we have a 24-inch telescope named after its builder, Mr. Kuhn. And so we have members going out there and doing observing, although during these times we discourage any gatherings, or we have suspended all our outreach activities. We have a quite active number of members who constantly bring out their telescopes, do sidewalk astronomy, or do outreach events for schools. And with the pandemic, actually, we have started to do some virtual outreaches. We have a couple of members who have remote observatories that they can control remotely, and they've been sharing their views with us. That had worked out great. And I believe the program just had was fabulous. You know, you showed us all those images, all the information. So that's great.
It's been a lot of fun to be part of, though, as well. You know, that is part of the work. There's a point where you realize you almost obsess over this stuff, don't you? So I've enjoyed compiling it, and it's been really nice to have you on board with us, especially tonight, to help this thing go along. No doubt everyone here, Reza, wishes you and everyone at Orange County and all your friends and family and loved ones just a really, really happy Christmas and New Year. And
thank you.
Please join us as well in the new year. It'd be really nice to have you on board and, you know, have this lovely transatlantic chat, because I think that's what astronomy has learned in the last year or so during the pandemic, is we can connect, we can still collaborate together.
Many years ago, we used to run, before the internet, long before the internet, a thing called the bulletin board. and we ran Starbase 1 and Starbase 4. And because Orange County at the time used to log on to it, they made me an honorary member at the time. I doubt if I still am, but way back in the early 90s, I was an honorary member of Orange County Astronomers.
Excellent. So you do have a history with us.
Yeah, definitely. Yeah.
Reza, would you be able... Oh, sorry. Go ahead, Reza. Sorry.
Yeah, so I just wanted to tell you that we are holding our general meetings now via Zoom. I don't know if the time would be good for you, but they're open to public, and everybody's welcome to join. They are on the second Friday of each month, and we advertise them on our website, ocastronomers.org.
Excellent. I'm sure that there's many of us out there that want to get really involved in that. So thanks for the invitation. Will you be all right to stick around with us for a few minutes after the show? Just to go through a Q&A?
Sure, I'll be around.
Super. All right. Thanks for chatting, Reza. So there's 10 minutes left of the radio show, and I'd make that around 6:20. So the voting should be in, and the voting should now be closed for the great conjurer of 2020.
Speaking of the vote, so I saw the URL you had on the sharing screen, but it was not clickable. So
it was tricky to get. I think it might have to come down to consensus at the end.
Yeah.
We'll see what we can do with that one.
Okay, if you can put it in chat here, or maybe on the chat in the YouTube.
Yeah, I'll get that done.
We're looking, Daz will back me up there because Daz is part of the SLU team. We're looking, maybe it's still looking clear over in the Canary Islands, so we might be able to connect at about 7:15, 19:15 UK time, GMT. So hopefully, what I'm going to do is after the show, I'll nip off for a couple of minutes and then come back, and I'll leave you to it. And I'll come back to broadcast the live feed of hopefully we'll see something.
Yeah.
But I shall leave it recording, and I shall leave it on YouTube in case we do. So
good things come to those who wait, Pete. So
we're waiting. We're patient. What do you think, Daz? Do you think it's looking good?
Yeah, I've been on the all sky cams. It's looking good there. The view off of the top of Tide is looking nice. It's quite nice and clear at the moment. I've been on the satellites, and it looks the cloud coverage is very, very, very thin, so we should be able to get something. The dedication on the telescopes varies a little. Most of them are sort of like 15, 20 minutes for the coverage, but I did notice T4, Canary 4, they've got 40 minutes dedication on it. So we should hope. Fingers crossed, we should get something.
Well, we'll swap between telescopes for different views anyway. But hopefully, we'll be able to go live at 7:15 with an actual live view of the conjunction. So keep our fingers crossed.
Fingers crossed. It would be nice if Rob Jeffries, who's on the line.
He is Santa.
Are we there, Rob? Santa.
Indeed.
Very festive hat. Yeah. We ran out of time really before, so we had a few more interviews lined up. But one really interesting thing about the two planets, Jupiter and Saturn, that we didn't quite have time to get into, but might have a couple of minutes now, is Rob was going to talk to us about the history of Jupiter and Saturn, and they weren't exactly where they are today when the solar system was
that's the interesting thing about a conjunction, isn't it? It's just a line of sight effect. I mean, Jupiter and Saturn are still almost 5 times the distance of the Earth is from the Sun apart in the sky. It is just a line of sight effect. But in the distant past, sort of in the early days of the solar system, some 4.5 billion years ago, they were much closer together, in fact. And really, it's a bit scary to think that our very existence really is down to a sort of game of cosmic billiards that played out way back then. And I mean, it's been known for some decades really that the planets in the solar system formed basically round about the same time as the Sun from a disk of gas and dust, which formed around the proto-sun, and the planets condensed out of that. But that simple model had some problems. For instance, you know, how do we get water on the Earth when you can't actually condense ice in the inner part of the solar system? And why isn't there a planet between Mars and Jupiter? There's just sort of a pile of rubble which amounts to less mass than the moon. And indeed, why is Mars so small when there should have been enough material to form a fairly decent sized planet there? And so a sort of new model, a more dynamic model of the early history of the solar system has been developed. It's known as the Grand Tack hypothesis, and this has it that actually Jupiter migrated inwards from where it was formed. So it was probably formed a little bit closer to the sun than it is today, and it then moved inwards. And this is you know, during the first maybe 50,000 years or so after the proto-sun formed, and as it did so, it sort of scattered stuff about and disrupted most of the inner solar system as it did so. But what happened then was that Saturn, which formed ever so slightly later, then migrated in as well, and the two planets got caught in what's known as a 3-to-2 resonance, so that Jupiter executed 3 orbits for every 2 orbits that Saturn did, and it sort of arrested its migration inwards and actually reversed the whole process, and everything moved out again, hence the Grand Tack, a bit like a sailing ship going around a buoy and heading back out again. And as it did so, it did loads more scattering, and as a result of that, the region between about where the Earth is now and where Jupiter is now got quite disrupted, and so there was very little rocky material left to form, well, what ended up as being Mars, and also very little to nothing really to form a planet in between where Mars is now and where Jupiter is now. And another consequence is a lot of the icy bodies that would have been able to condense quite far out in the solar system ended up being scattered inwards by all this moving about, and that's probably where the water on the Earth came from. So it's a very dynamic process.
Definitely, it's had quite a history, hasn't it? Now, I realise that we've only got 3.5 minutes left, so this is an unfair question in a sense. We're supposed to have a chat with Pierre Maxted if we had the time, but once upon a time, there were 9 known planets that existed in the solar system. One of them was relegated to a dwarf planet in 2006. Yes, and well, there are a few more than that are known these days, aren't there?
Yeah, I mean, dwarf planets as a category now. I forget how many there are actually. I mean, Ceres, the sort of largest body in the asteroid belt, is one, but there's also I think another 3 now, which have been discovered out beyond the orbit of Neptune. Basically, all the kind of Pluto-sized bodies. There's one called Makemake and one called Haumea, and Eris, and one or 2 other things that are lurking out there, sort of so-called trans-Neptunian objects, and they're really icy bodies that are very primitive, actually formed way back in the course of the solar system, and they may well not have formed as far out as they are now, because one of the byproducts of this Grand Tack maneuver was that also Uranus and Neptune probably moved outwards as well in the first, certainly in the first 100 million years or so of the solar system's existence, and they would have scattered some of these icy bodies outwards into wider and also slightly more chaotic orbits. I mean, many of these distant objects from the sun don't orbit in the same plane as all the planets. They're a bit more scattered. So that's probably the origin of some of these dwarf planets.
Yeah, I'm sure that,
including Pluto. So Pluto is really the prototype of these things. It is really a large Kuiper belt object.
Yeah. So as researchers like yourself and I look out not way beyond into the cosmos, but at least into the solar neighborhood of stars, there's still a wealth of information to learn about our own system.
Yeah, well, it has to be said, this sort of Grand Tack hypothesis was really prompted by observations that were made of exoplanetary systems, including exoplanetary systems actually found by Keele astronomers. The so-called Super WASP experiment was very successful at discovering so-called hot Jupiters. These are giant-sized planets very close to their parent stars. How did they get there? They can't have formed there because it's far too hot to condense gases into giant planets. So they must have migrated. And that's what got people thinking about a solution to these various problems about solar system formation that can be solved by having all the planets moving around during the early solar system's history.
I should take this opportunity now, with it being 6:30, for listeners on the radio, if we're still there, just to wish them all.
It's all right. I've already
Happy
done
Christmas.
that. I've already done
okay.
that.
See.
While Rob was talking, I faded that out and did the radio bit without it interfering with the Zoom bit.
Pete's the only professional astronomer you see around us.
So it'll all carry on YouTube and zoomed out till you want to finish. Effectively, I've actually set it to run till midnight, so it can run as long as you want it to run.
You wish.
We're in overtime.
But as I say, I'm just going to go and grab a bite to eat. You carry on and do your question and answers.
That's
And
okay.
and I'll be back before 7:15, so we can go live to Tenerife. And it's still looking good at the moment. The domes are open, and it's looking good.
Yeah, super stuff.
So I'll be back in a sec.
Yeah, no problem. I think what we'll do is, Jordan.
Yep.
If you're around, can you see where there have been questions posted? There'll be some in the chat. I think it might be good just to go through a few of them, and then when Pete comes back, we can, if he can help us by moderating the question and answer session there.
I'm just having a look on the YouTube stream as well, on the chat window there. Obviously pausing that, I don't want it to interfere. So I can see one question, which is from Zantiverni. I hope I've said that right. And it's, where do you look for the Jupiter and Saturn thing? North, east, south, or west?
So what cardinal points on a compass should we be pointing at?
Sky do you look?
So if you're in the northern hemisphere, you'll be looking in a southwesterly direction. If you're in the southern hemisphere, it's slightly more towards the west. And when you observe this thing, it's only going to be slightly above the horizon, so you don't need to look too high up in the sky. Most places around the world, it should be around 10 degrees above the horizon, so only really just above the treetops.
Yeah, you're just looking for two closely separated, what will look like stars in the dusk sky. You probably just be you'll be able to make them out as it becomes twilight, and then they get obviously brighter as the sun gets below the horizon. And you've got about an hour, something like that, before they themselves will just follow the sun down below the horizon.
Yeah, that's right. Depending on where you live, there will be a slightly limited amount of time through January to observe it. But at least in the next 2 weeks, from the UK at least.
Yeah, it's important to re-emphasize that although it's cloudy tonight, there should be no problem in seeing these two planets very close together for the next week or two, in fact. And as I'm pretty sure somebody did mention, there's actually a pretty decent weather forecast in the UK for Christmas Eve and Christmas Day.
That's right.
So it's quite likely that there'll be some good viewing conditions then.
Yeah, and of course they will be slightly separating, but it will still be a real spectacle to see before it falls apart. It's
sure. I mean, I looked at them with binoculars it was more than a week ago, and they were well inside a binocular field of view with the binoculars I was looking at.
Yeah, one thing I certainly found interesting is I didn't expect to get a picture with my camera phone until I went out and did it. And that's part of astronomy sometimes is, well, you can have all the theory behind you, but sometimes you just have to look.
Well, yeah, bit of experimentation. Yeah,
that's right. Yeah, so yeah, I would
There have been
encourage
many
anyone.
times where I've looked at something that I've never ever seen before, and still when it pops up on the screen or it pops up in the eyepiece, depending how I'm looking at it, and it's just the awe of looking at something so beautiful. And especially when I saw Jupiter and Saturn for the very first time back in the first lockdown, I think it was, when I first got my new telescope, and I just looked at them individually, and it was just incredible. Obviously, you see it in the night sky, but when you look at it through a telescope or through binoculars, you see that detail. It's just beautiful.
Alex, do you want to show my clip about yesterday? Or you want me to do that?
Yeah, would love to. Yeah.
You want to do it or I share it?
Pat, I do have the video, but since you've got it there in front of you, maybe it's best if you share it from your side, Jacko.
You disabled attendee screen sharing, though.
Sure.
Yeah.
So you got back okay from the observatory?
Yeah.
Yeah, great.
But it was murky, just like on Titan, as I said. What can be better than walking in the rain on Titan? That's why it's much better than Mars. I mean, people want to go to Mars. They have this obsession, but all you can wish for is a good dust storm, but it never rains on Mars.
Yeah.
Right. I still can't share.
Okay. Is there a share screen button for you?
Yeah, but you have disabled it.
Sorry, bear with me.
So yeah, yesterday I got my 8-inch Smith Cassegrain out. It's not some medium-sized telescope, but you don't need such a large telescope. But I just mounted my DSLR on it, and I mean, it's amazing how sensitive DSLRs are nowadays. I used to take slide films. Any of you know what it is? A piece of plastic with some chemicals on it, and you would be able to take pictures of bright things like Jupiter and the moon. That's not a problem. But then I took a picture of the great globular cluster in Hercules yesterday after Jupiter and Saturn had disappeared behind the clouds. And even though that's Messier 13, it was quite low in the sky, so it wasn't the best. Just 10 seconds with this DSLR on the telescope, and it's just amazing. I could never do that with a slide film.
Yeah.
Well, you could, but not at the time when I was a teenager.
Did you manage to get that screenshot at all?
No, it still says disabled.
Okay, I think what I'll have to do is come off that. Maybe it works now. Yeah, sorry about that.
Crank up the audio, probably. I think it was a bit low. It's just a minute, so anyone who doesn't like the sound of my voice, you won't be in agony for too long.
I think people have been tired of listening to mine for a couple of hours now, so I'm sure they'll be happy to listen to you, Jacko.
Yeah, so on the one hand, it's nice to take pictures, but on the other hand, people are obsessed with taking pictures, and it's much more important to actually look at it with your eyes and take it in before you actually start fiddling with equipment. So that's my advice for people. Well, it was brilliant looking through the telescope to see just Saturn and Jupiter and the moons all together in one view. Well, you've seen them separately, so in that sense, it's nothing different. But just to have them together,
yeah,
and you almost get a sense of that because Saturn is smaller, but it also looks smaller because it's further away. So you have the sense of looking through the solar system out. I think there's some chats coming in as well.
Yeah, Jacko, in the meantime, I do have your video at my end. If we're having a bit of trouble sharing the screen, I can always run there.
I'm just going to mention that...
I can share it now, yeah. I can share now, so okay. Yeah, shall I?
Go ahead.
Okay, there we go. By the way, Mary McIntyre says, very clever. She set up a second telescope so she could both take pictures and actually view it. That's a very good idea, actually.
Yeah, where's evolution with that third eye when you need it?
All right. Okay, it wouldn't let me get the audio. I have to install Zoom audio device.
This all builds, am I right in saying, on what happened in Liverpool a little while ago now? Yes, Liverpool, of course, like most of the East Midlands, were in Tier 3. They've managed to get from Tier 3 to Tier 2. And a lot of people credit the rollout of mass testing there involving the army.
Oh, I think we got a bit of local news there.
We have, yeah.
Yeah, I don't think that was me sharing the audio. If I can't share audio, it tells me I have to reinstall the audio device or something.
That's all right. I think it was just one of the participants, so sorry, I just had to mute it for a moment.
So yeah, that's a nice thing that you can look at the Great Conjuncture without any telescopic aids. Of course, for the visually impaired, this is a bit more difficult. So here you really have to imagine, these objects so close in the sky, and also imagine what people made of it in the past. And all we knew about planets was just that they move in a different way from the stars.
Yeah, Jacko, can we see?
Yeah,
that window there. So we'll just play this. This was yourself last night at the observatory, wasn't it?
Evening. It wasn't too bad. There were some clouds in the south, so that did spoil it in the end. So I didn't get time enough to get a good picture, but I did get a picture, and I'll show it on the back of my DSLR in this little clip.
Great stuff.
Hello, it's Sunday, 20 December, just the day before the Great Conjuncture. I've set up my telescope, just here above the horizon, and I've mounted a digital camera, just an ordinary DSLR on it, and took a picture of it, and here it is. So you see, there's Saturn at the top and Jupiter at the bottom. So the way you take a picture is you set it to manual, and you've removed the lens, so you don't need to worry about the diaphragm. And what you do is you play with the exposure time, so that you don't overexpose and it becomes just a big blob of light. These cameras are quite sensitive, and Jupiter and Saturn are quite bright. So here I took about 1/60th of a second. If you take a short exposure, you can actually see a little bit more detail in the rings and on Jupiter itself. So here's hoping for tomorrow.
Excellent. So that was Jacko yesterday saying, here's hoping for tomorrow, yesterday, and here we are today. Never mind. I'm sure we'll get something. How are you doing, Kath? You all right?
I'm good, thank you. Yes, yeah. I've only just got into Zoom though. I was having some trouble with it. But yeah, I just put in the chat. I was so glad that I was over in Oswestry last night. I popped by Pete's, only socially distanced, on the doorstep to drop off something for Christmas, and then I went to his daughter's, and his daughter there's a bit of a hill at the back of hers, so I was like, come on Sarah, we're going to go and look for these, and we literally got up the top of her road, and there was literally a 5-minute gap in the clouds, so we did get some snaps. I took my DSLR, but I didn't get the focus quite as I wanted it. It was just a little bit off, but we got some phone snaps and stuff, so that was a bonus last night. It was really nice. Yeah. I'm glad we did that. Yeah
I get it is one thing that connects perhaps being in La Palma to swinging a pair of binoculars around wherever you are, is that in astronomy, anytime you say, oh, I've had enough, let's call it a night, that's when they all come out to play. So,
Of course, yeah.
so with
yeah.
this conjunction, I had the same thing with Oliver, who was on the show a couple of weeks ago, where we went to the park and we were just about to say, come on, it's not happening. And every time we said it, there would just be like a perfect donut shape open up in the clouds to reveal them. So, yeah.
Oh, brilliant. No, it was. I think it was just luck of the draw yesterday, and I know I can see there's some people from Wolverhampton Astro who are on here as well. I know they went to a place in Bobbington, just outside Wolverhampton, and they all got some really good photos. So yeah, I think last night was definitely the night, wasn't it, for us in the UK? Not tonight.
That's right. Yeah, I mean, as part of that competition, the last couple of weeks has been, for want of a better word, just trawling around the internet trying to, get snapshots from people around the world. So it's kind of given me an idea of what the conditions were like on certain nights when you look back. And really, last night was the best one, it seems, in terms of clarity.
Yes.
Some of the most interesting ones, just for the visual impact, were around the 18th when, of course, the crescent moon was passing by as well. Yeah, so
I didn't really see it. I think before last night, the last time I actually saw them really clearly was on the 12th. I've got some photos from the 12th, and of course they were a lot further apart then. But yeah.
Kath, you said I saw your images earlier.
Oh dear. Don't tell people how bad they are.
I've got a like. Oh, they're atrocious. Oh, I wouldn't have bothered. No. No, you said that they're just slightly out of focus. Now, I find, and I was speaking about this with some other people on another show, that sometimes when you've just got that just slightly out of focus, and it appears on yours, you've got the difference in colour between the two.
Yeah, I got the colour.
That looks really spectacular. So, although you say it's not as sharp as you would like it, it looks really nice. So don't go beating yourself up that it's.
Daz is my new best friend, Alex.
I
did. Somebody else put that on Twitter. They said, "But you've got the colour," and I was like, "Yeah, well, that's true."
Yeah, that was me. Yeah, that was me.
Was that you? Was that you, Daz? Oh yes, yeah. I think someone else did. No, somebody called Alistair did as well.
Oh, okay then. Yeah, well, see, there's two of us, two people with taste.
Got to be right.
So they come out very well. I got some last night as well, but I had the wrong lens on. I had a 70 to 300, and I was using it at 300 mil. And basically, I've got a nice separation of them. But then when you look at them, you think it's just two stars with a gap between them. So I made a cock up there, but I'll know for future reference in 40 years' time, I'll get it right.
Oh, that's the thing, isn't it? Oh gosh.
Yeah. So there always seems to be a bit of trivia or something happening that's involved in every conjunction. I don't mean it in any kind of astrological way. I just mean events that were occurring during the time. Someone sent me an image that I didn't have the time to add into the presentation, which marks around 1400 BC. And it's from obviously the Egyptian period. I'll try and share the image and the details that go with it, because the actual details have lost me. But that probably marks the first ever recording of the Great Conjunction.
Oh, ask Pete, he was around then.
Yeah.
He was a lad, but he'll remember it.
Let's hope he doesn't watch the playback for this bit.
He's gone back to his cryogenic tank, hasn't he? He'll never have me back on here.
Oh, you'll be on the naughty step with us, Alex, as well.
Is Oliver patented his Oliver? Yeah, I mean, his seeing schedule thing. I can't remember what he called it now.
Well, it's like a magnitude scale, isn't it? Where
that's right. Yeah,
using faint stars, bright stars, the moon, and what he called the Oliver scale, which
it's Oliver scale, exactly. Yeah, because it was taken up in Moscow and in China, wasn't it? So it's all over the world now. So yeah, well done.
Yeah, no, he's done really well with that one. He's really been enjoying his astronomy and getting in touch with you guys. So,
oh, excellent. Yeah, he's always welcome on the show. So yeah, pop in and we'll have a chat with him and all that. So he'll probably be teaching us soon.
Exactly.
Yeah. Bring a bit of sanity to the show as well. You know what
That's
someone
right.
get like.
Yeah, we do get a bit silly, don't we?
Yeah. What we got?
So if I may interrupt a little bit here, so I see Kath Adams from Wolverhampton Astronomical
That's right.
Society. So I'm interested to know a little bit about your society and the stuff that you do there.
Okay, well, obviously we're the Society for Wolverhampton, and basically, I mean, at the moment, obviously everything that we do is via Zoom, although last night, as you might have noticed in the chat, a few of the guys actually went down to a place called the Vineyard in Bobbington, and actually did some observations of Jupiter and Saturn there for the conjunctions. I think there was about 13 members actually met up last night, obviously not all together. They were all socially distanced using their own equipment. That's the first kind of event that we've actually been able to have for, obviously, since the beginning of COVID. But at the moment, as we're running lectures about every 2 weeks, we're just in the Christmas break. And we do try to do meetups for special events. We did one the other year for the transit of Mercury, again at this vineyard. I promise you we're not drinking wine all the time. We are actually out observing, because it doesn't sound good when I say we're at the vineyard observing. I would like to say we are there with our telescopes and cameras, and yeah, so that's the kind of thing that we do, as I say. Yeah. I
mean, the thing is that this whole situation has made people use social media more, and Zoom and etc. And so it's possible to have meetings across the world, which we used to do. So you can just have somebody talk from the other side of the world, which is that's a positive, and we should make use of that in the future as well, to be more connected.
Oh, definitely. I think it's connected. I mean, I've certainly met a lot more people, obviously only online, but it's just incredible the connections that you can actually make with all these different shows that are going out that Pete's doing on Astro, and different things like the Society for Popular Astronomy that I'm also, I'm a council member for them in the UK. They do their own show on Facebook. But there's so many different ways that we've all connected, and as you say, you get invited to talks that are being held on the other side of the planet, and it's just amazing.
I saw an image that one of your members, Reza, in Orange County, which was a really nice one. It's taken from, let me get this right, a place called Fullerton near Los Angeles.
Correct.
Yeah, it was really nice. You got like the whole conjunction. It was just overlooking the skyline of LA. It just had like a real dramatic impact where it was far enough away in terms of altitude. Sorry, in terms of, you know what I mean, altitude, the height that Jupiter and Saturn were above the city, that it didn't have any light pollution. But it just looked like 2 extra lights above the city. That was a really nice one, I have to say.
Yeah, I voted a couple of minutes ago, and I realized there are a couple of familiar names over there, so that was nice.
I managed to get some in on time then.
And yeah, you've got from all over the world, right? That's great.
Yeah, it's been a long 2 weeks of saying pretty please to a lot of people, I guess.
So have you been reaching out to them via Facebook all the time, or you have? Where did you find all these guys?
Facebook has been the main sort of avenue for it, you know, various astronomical societies. A lot of it has just effectively been amateur astronomers posting their pictures up. As well as that, there's other websites like Flickr and Imgur as well, things like that, that, you know, you see these shots and some of them, you would easily have it as a poster on your wall. You know, there's some really great ones in there. That's why I had to split it up between professional photographers and people just who wanted to just capture it. Because has anyone else got a favorite? Maybe not necessarily from the ones I showed before, but a favourite shot that they've seen of this conjunction.
Pete Lawrence has done some nice ones, sky, which he would obviously because he's a sky at night person. But he's had some nice photos out there. Mary's there. She's there in the chat. Her photos, as Pete showed, fabulous.
Yeah, Pete. Pete posted some, didn't he, from his bedroom? That's the graveyard, isn't it?
Oh, Pete, he does. Mind you, he gives us enough, doesn't he? So
too right. Yeah.
No, he did venture out up the road. He did. Yeah. He did
to the church graveyard. That's because it's the best viewing point for him up there, isn't it?
It is in Witchington. Yes. Yeah. It is. Yeah. It is. I'm trying to think. I did see someone else's photo online, and let me have a look on my Facebook. I'll have a look on my Facebook. I saw another one earlier, and it was fabulous. Damien Peaches put something on Twitter tonight. I don't know if it's taken in the UK or if it's one of his Chile ones. I'm just gonna have a look. That popped up not long ago. Let me have a peek and see. I would imagine it might have been in Chile. Mind you, he's South Coast, I think, isn't he? So he might have got it.
Mary McIntyre says he was imaging in Chile.
Was it? Okay.
Yeah.
Yeah, I can't quite work it out. I'm just looking at his present. Yeah, I'm just trying to look what it says on his screen. Yeah, I think it
made me laugh then because he's in Chile and it's only mentioned about rice before on a tripod. Chilean rice.
Yeah, it's that's for binoculars, or even for the camera. If you haven't got a tripod handy, usually a fence post or something like that. But if you happen to have a bag of rice, which you don't normally have in your pocket, but if you've got a bag of rice and you just put it on top of a wheelie bin with the rice, you can squish it round and actually get the binoculars or whatever to sit just right. And if you've got a chair, you can just look straight through it. So it's a handy little tip. Just always have a bag of rice with you. So there you go.
Could absorb the dampness as well.
Put one in my handbag then.
It just sits nicely on there and it doesn't slip around. It's a good little tip, that is. Or on the top of the car or anything like that. It's if you're taking a long shot or a zoom shot, just to hold it steady. So
I've got a really mini tripod. It's like tiny, but it just does for the phone. Yeah, it just does.
Mary says small bean bags as well. So yeah.
I was once photographing the comet and it was hard to see it, so I had 11x80 binoculars on a tripod, and then I fastened the digital SLR on top of the binoculars, so I got the actual comet then, because I knew the binoculars were looking straight at it, but I couldn't see it with the camera, but I could see it with the binoculars, and then I managed to get it with the tail and everything.
Spotting binos, that's nice. Yeah, not a spotoscope, but spotting binos.
Yeah, expensive way of doing it.
I just need to pop out for a few moments, but I really want to come back to see this Canary Islands.
Yeah, you've got about 15 minutes, just over 15 minutes before the first mission starts.
Yeah, I'll be checking that out, no problem.
Is that Damien's one? Yeah, it is, isn't it? Yeah.
Oh, sweet.
Yeah, very nice.
Very. Yeah, so he's got Saturn's moons as well. Lovely.
Yeah, there's several there, isn't there? 4 or 5. I can see 4 or 5 dots. I'm not sure if they're anything else random, but
no, look for those in the right place.
They look like the moons, don't they? Yeah.
Jupiter's got the extra star.
Yeah.
Well, Mary's in the chat. Oh, Mary, come on screen. Oh.
I can't. I've been baking. I look like a mess. I can't put my camera on.
Oh, Mary, I can't believe you look terrible. What you been baking, Mary? That's what I want to know.
Well, Nigella Lawson butter biscuits and some peanut butter cookies
Oh, yummy.
Gifts for some of my friends in the village. I'll give them out before we get locked down again.
Oh, yeah, yeah.
I
thought we
those to be sent to us. We are quite hungry, you know.
Yeah,
yeah, you can them, that's for sure.
We'll all start private messaging you with our addresses, Mary.
Just a few batches here and a few batches there.
Oh.
Plus, we're used to cookies on the internet, aren't we?
Oh, very good.
Cookie warning. But after the first lockdown, I needed an actual cookie warning. It was just too easy to keep eating biscuits.
Oh. Yeah, terrible. Mind you, I've had 3 boxes of chocolates given to me at work today, and I'm like, no, please. Like, people who've been really grateful for my help over the last few weeks when we've opened up, they're like, we bought you some chocolates. I'm like, thanks, thinking I'm never going to get slim. I'm just never going to get slim.
Re-gift, that's the key.
Yes, but Mary, you've seen me eating chocolate and cake. It's not likely to happen, is it?
I couldn't give away chocolates that were gifted to me if you gave me money to do so. So
No.
feel your pain.
Yeah.
Chocolate is the reason for being.
Yeah. I'll open them and share them with people. That's what I'll do tomorrow.
Yeah, take all your favourite ones out first.
Absolutely. No one gets the Maltesers.
Oh, no.
Kath's finished all the wrapping now. You were wrapping on Saturday, weren't you? All your Christmas wrapping.
Oh, I was, yes, yes. I was.
I've still got loads to do.
Oh, I was absolutely, my back was killing me because I was sat on the floor for I don't know how many hours doing that wrapping. Yeah. Multitasking.
Yeah, that was a good show on Saturday, wasn't it? It was very good.
It was, yeah. It was good, really
Yeah,
good.
it went quick actually the time.
Mm.
So it's better than
we
watching
we
TV.
must say no more singing.
No more singing. No.
Yeah, we do band practice using an app called Jamkazam because it irons out the latency. You just literally cannot sing together via Zoom because everybody's internet is different.
You could blame Tracy now for the cloudy, wet weather.
We can. I think the trouble is, though, if we'd have been ironed out through that jazz, because that you were saying, Mary, it would have highlighted actually how bad at singing we all were. We could all blame the latency on Zoom up until that.
Pete's back.
Oh, Pete's back. Shh.
Yeah.
Hello, boss.
You have to say what a fantastic bloke he is now.
Oh, right,
Yeah.
okay.
Can't fault him. He's a god.
I'm saying nothing.
Don't watch the playback, Pete.
Always gone serious.
No, I was just keeping my eye on Slew. They're doing a bit of a presentation, but it's so quiet I can hardly hear it.
Yeah, that's probably the best way to be.
But as soon as the images start coming up live, I'll share them.
Yeah, all the domes are open, so we're okay. And it's I think it's 1:15. The first missions as they call them start.
Yeah, they're basically running through kind of the stuff that has been run through here tonight already. So there's no point in broadcasting that bit. But like I say, I'm keeping my eye. As soon as the live views start coming up, we'll go for it. Oh, who shared that one?
That's a good picture.
Yeah.
Whose is that?
Rob's.
That's Stellarium, isn't it?
Yeah,
so
I believe that is looking on Stellarium, yeah.
Yeah, so you can see which one is the star.
Yeah, not real.
Yeah.
Down the bottom.
Yeah, so we saw Titan, and we did see at least Rhea, and on the other side, well, one of them, Dionysus, on Damien's picture.
Yeah, very good.
When you look at Damien's picture, it's very clear that Jupiter and Saturn are so bright. It's very difficult to take a picture that shows both the moons and the details on the planets. So you have to do some image processing to deal with that dynamic range, but I'm sure he will do that.
He's just put it up, Jacko. Jacko, am I pronouncing your name right? Is it Jacko?
Yeah, that's fine.
He's just 20 seconds ago, he's just tweeted an image. It's, oh my goodness.
I've been waiting for this.
Oh,
and then Saturn's, it's the other way around with Saturn beneath, is it?
It is, yeah. It's absolutely stunning. My goodness.
Yeah, because he's standing upside down. Yeah.
Wowzers.
I was trying so hard last night when I was out with my telescope, because I was having that trouble with the brightness of Jupiter. It was completely ruining my my focus for Saturn. So I was having to adjust it, not perfect, but it was just getting to a point where I was freezing, and I just took an image of whatever was it was on the screen, so it just went.
Yeah, that photograph of mine that you showed earlier is actually a blend of 3 different exposures. So you could see that one cloud belt I got on Jupiter, just make out Saturn's rings without it getting kind of too dim, because you got to turn the brightness down on Jupiter. But then, so that was a parallel process on one set of images, and then there was a second exposure that was up at a higher gain on the camera to pick out the moons. So I had to do 3 different pictures together to get that picture. Doesn't look it because they're tiny through that refractor, but it was a lot of work to get that picture.
Yeah. That's it, you see, because when you get Jupiter's moon, you don't get banding. So you have to adjust it. Yeah.
We've all gone very quiet.
I haven't. Well, I've just had my tea. I've just had chicken Alexander, but there we go.
Have you?
Well, you know.
Very nice.
One has to. No, it's all right. I'm just keeping my eye on the telescopes, just waiting for them to come online.
Cool.
So I can share it immediately.
Yes.
Did you not have a pudding, Pete?
No pudding. No. No. I just looked outside and I could see the moon through the clouds, but I tried to see if I could see Jupiter and Saturn through the cloud, but no chance.
No.
It's getting a bit late now. I think they're set by now.
Yeah. They were set, weren't they?
Pretty much.
What a shame. What a shame. Never mind.
So, Pete, what's the soundtrack you're using for this show?
No soundtrack at all.
No,
it's a soundtrack of the universe, or you lot talking, to be honest.
Dear. Yeah.
No, we could put it to a soundtrack, couldn't we? What could we put it to? Sun, Moon and Planets by Babe Ruth.
Yeah. As long as it's not us singing, that's the main thing.
Oh.
Oh.
Can you actually see that?
Yeah.
Yeah.
Yeah, that's after freezing for an hour or two. That's what I just thought I'd take, but I know it's not exactly in focus, but the wind was also quite a problem as well. Because where I am is quite high up, and the wind does.
Yeah.
It just hits the telescope with quite a lot of force.
It does show.
But yeah, I was quite surprised when I took that. Sorry, Jacko.
But that's focus probably because it's quite symmetrical with the dark spots in the middle. So it's more likely focused than jitter. It's quite difficult to get focus, actually.
Yeah. One of the moons is quite close to Jupiter there.
It is there.
As one of you said, to get colors out, it's good to not focus too sharply, but of course you want to see details on the planets. You do want to focus.
Yeah. No, I had quite an orange Saturn last night. But
I took a picture of Albi Rio. If you know that's a double star in the bottom. Well, the tip actually of Cygnus. So you got a quite stark contrast in color between the yellow star and the blue star. And indeed, the focus wasn't perfect, but you could see the colors much better.
That was one of the first things I actually went to after observing the conjunction. I thought, well, try the camera out on something else, and I went straight to that. But I didn't take a picture of it. Too cold for me.
Oh, call yourself an astronomer.
Did you?
I've been out for a few hours previous, so I'm
the same as you. I mean, I do all the image consultancy and that for some for NSO and some for Forks. And so I never go outside with a telescope unless I really, really have to. So I just sit at home and do all my stuff.
I don't mind the cold. It's just when the wind is quite bad. It just makes it worse.
It
What
was
camera were you
windy last
using?
night. Yeah, it was.
Was it a camera attached to your telescope?
Yes, I've actually got it here. I've got the ZWO.
All right.
ASI 1600.
All right, that's good.
What you might be worth doing is focusing on the moon and then going back to Jupiter and Saturn. So
I did that
because you can
multiple
tell from the moon, and
times,
you got your focus right.
Yeah, I did that multiple times, and then I realised that what I kind of do, and I do this every single time. I'll always, if the moon's there, I'll always use that to focus, and I'll move to whatever I want to look at. But then I'll find that I'm just adjusting it slightly, but I don't realise that I'm shaking that much, and I've turned it way too much, and I've got to do it all over again.
Yeah, because when I use a digital SLR, I can connect to the laptop and do live view, and then you can actually see that it's sharp focused before you actually take them.
Yeah.
Or take a series of pictures and just slightly move the focus.
Yeah.
Make sure you focus slightly out of focus. You see it slightly out of focus. Remember which way you turn it.
Yeah.
And take a picture and then start turning it the other way, ever so slightly. Take picture, another picture.
And then
until
the
you
other thing
see
I do is bracket shots as well. And then that way you get a good sort of image. You might get one too bright, one a bit duller. By bracketing your shots, you've got more chance of getting one clear.
What I sometimes tend to do as well is I put the exposure down very, very, very small, so I can see that the quick movement, and then I'll do it that way, and then I'll slowly increase the exposure to see the changes. And that does seem to work okay, but it's a bit time consuming.
Is your telescope tracking as well?
Yes, I have the Celestron Next Star 8SE, so it's only got the alt-azimuth mount.
Yeah.
But I do have a wedge. But to set it up for polar observing in terms of the equatorial, I just find it's such a pain to do.
Yeah. Especially if you're carrying up. Did you say you had to carry up a hill?
No, where I live on sort of a platform, so I just have to take it out the front door, but it takes about 20 minutes for me to do a full sort of setup.
All right. I remember once when the transit of Venus was on, and we camped overnight, and we got up in the morning, and the first 5 minutes of the transit of Venus, then we lost it for 2 hours until the very end.
I'm just having a bit of food, and my better half just sent me that, so I thought I'd share it with you.
Oh, yeah. Yeah, it's a good one.
Whatever you do, don't send that to Boris, because he might say that you're breaking the law.
Yeah, the social distancing has definitely gone out the window.
Oh,
well, how long to go? 3 minutes, and hopefully the telescope will come online and we can go over to it and see if we can see anything.
Yeah.
Cool.
Hopefully.
That'd be good.
It would be.
Yes.
Whether it's going to happen or not is another matter, but it will be good. I'm keeping my eye on.
I reckon the Thursday night's going to be clear.
Yeah, but they'll still be quite close, won't they, Thursday?
Yeah.
So
yeah,
be nice. I might try and get my camera in focus Thursday night.
An ISS transit on Christmas Eve, and it's due to be clear, so fingers crossed I'll get that. I think it's passing the sun on Christmas Eve.
I'm on the radio on Christmas Eve.
Oh,
so you can send me the pictures while I'm on the radio.
One thing I've always fancied doing at Christmas is getting away and going to an observatory and just spending Christmas Day and Boxing Day in the observatory, and even if I only had cheese and onion sandwiches, I'm not bothered about turkey. Just always wanted to get away from all the commercialised side of things.
You're not bothered about turkey. We have a backup turkey, and a backup for the backup in case the backup fails.
No.
Oh, that's Sib organised, bless her heart.
If I was in an observatory for Christmas, I'd be happy with a pot noodle, to be honest.
Yeah.
Yeah, me too. I'd be okay with that.
Some of the people I go and see, they just sit watch telly all day, one thing after the other, and I can't do that.
No. Well, I can, but
Oh, I can't. I can watch one program and that's it. I've got to be out doing things.
yeah, I can. Depends how much. If I've eaten too much, I can easily do that. But
that's because I fall asleep. But we've seen the TV schedule, and I'm struggling to find one thing that we'll be watching. So if we do anything, it'll be DVDs.
There's some Christmas lectures coming up, aren't there?
Yeah, we usually watch those.
Yeah, that's something worth watching.
Yeah, the general TV.
Kind of lectured out this year. It's been a lot, hasn't it?
I know they start second week on BBC 4 for 3 nights.
What's that?
Royal Institute Christmas lectures.
Oh, okay.
Yeah, they start on the bank holiday, 28th of December they start. Professor Chris Jackson, the first of 3 lectures on the hidden wonders of the earth.
Oh.
So I'm not ready.
Okay.
Did anyone get the chance to see Exeter University's material?
No, I didn't get a chance.
If you do, it's really nice. So they did some live observing yesterday.
Yeah.
I think, was it like 4:15 till 6:15-ish? They just did a really good job of it. So it was Matthew Bate and Chris Reader and Chris Brunt. Sorry, Stephen Reader and Chris Brunt. And yeah, they managed to get some really nice, live streaming. That was just from the rooftop on the physics building.
Oh, nice.
It's been put on YouTube, and if you go to the website, I'll tell you what, it's jupitersaturn2020.org.
Yeah.
And they've got loads of nice material on there as well. So, you can just, if you have a few minutes and, you want to find out more, then they've got some really nice stuff on there.
Just keeping my eye open. Not great, but it's a live view, so we'll go over to it. I'll swap between the telescopes every so often and see what they got going. So, can you see that?
Very nice.
Nice, yeah.
Yeah, good.
It's a live view, so that's on that. Let's see if there's anything on Canary 1 yet. Oh, looks like there might be. Oh, Canary 3. Have I clicked on the wrong one? Canary 1. There we go. Same on Canary 1. So we can see how close they are, and obviously with the moon, you're saying the moons will probably be overlapping, won't they? We'll go to Canary 4, and we'll just keep swapping back. Canary 4 is
2
not
of the
online.
moons are very close on that picture. Then
yeah, I'll go back to that.
There's 2 moons very close.
Was one of them the star? They looked to be 5. Or would that be
probably a star, or it could be a moon? That's obviously a higher res, closer in, overexposed image, but that's looking how close they are.
Yeah.
Go back to is it 3? We'll try 3.
So Pete, can you explain a little bit how does this sleuth work right now? Are you ordering images, or they just stream?
No,
it
they're stream. If you join Slew, you can program for time. You can schedule your own observations, but because of the conjunction, Slew have grabbed all the time for themselves. But you can just click on the telescope and see what it's actually looking at the moment. So they're streaming it live. So that's a live stream from the telescope.
And so is this a live stream, or is this a sequence of images every few seconds?
Yeah, it's what it's doing. It's taking a CCD image, and then it's obviously feeding the CCD image, and each time it feeds it, it'll build up. I don't think we're going to get much more than that, but at least we're seeing how close they are.
Yeah.
Yeah, this is great. But in normal times, then you'll be assigned a certain time
Yeah, you
slot
can. Yeah, if you join Slew, you could. There's 2 ways you can use it. You can join Slew, and you can then schedule your own observations. But if you don't want to schedule your own observations, you look at what other people are doing, and you can join their observation if you like. And if you click join their observation, when their observation is finished, it will send you their data as well. So it's like a community where you share data. It's a US based company. I'm not sure where they're based in the US, but they've got telescopes in Chile and they've got telescopes in the Canary Islands. Obviously, they've got this Jupiter and Saturn are going to be higher up in Chile at 1 o'clock in the morning, our time. So they've also scheduled to run an event at 1 o'clock in the morning UK time from Chile as well. So you can go on and have a look at that. But yeah, I mean, if you join SLU, you can join SLU as a student, and it's only about, I don't know, I think it's about $2 or $3 a month as a student. And that allows you to take, I think, about 5 pictures a day. Daz will probably know more about this costing than I do, but it'll allow you to take 4 or 5 images a day for that. I think it's just going to try and take another photograph now.
Thanks.
Yeah. So it's just go to slu.com and all the information's there. And there's lots of outreach stuff on there as well for people to use, you know. So if you want to do projects with your society, there is a load of stuff on there that you can do, especially for the younger members. I wouldn't say it's if you really are an experienced astrophotographer, it's not for you because it's for beginners. But it is great for beginners who've never done anything like this before. So it's well worth having a go at. Just get the society to have a go at it, and you can buy a society membership, and then you can go on and take part in some of the projects. And they do a lot of virtual star parties as well. That's again, they're still looking at the. I mean, that's a 500mm plane wave telescope.
Wow.
There, so it's going to be a small field of view on that one. But you know, we're seeing it live. We didn't think we'd see it. We're seeing it. So in one way or another, I don't know if Canary 4 is back on. Canary 4 doesn't seem to have come online for some reason, and it was scheduled to come online for 7:15. But we'll go. But I don't know what 3's looking at. Usually tells you what it's looking at the top when it's doing it. I don't think Canary 3. I think they may have got cloud by the look of it. There's something going on. Canary 2.
I hope the volcano hasn't erupted, Pete.
It looks that way. They ain't got a lot going on, have they, at the minute?
It's a bit worrying.
Even though we managed to see it for about 30 seconds, we saw something.
We saw it.
Clouds. What can anyone do? Clouds get in the way.
Oh,
we've only waited 800 years for it. Clouds come over.
At least it's still there. Now, say, for instance, you're Reza, if you're a student user and you want that photograph, all you do is you go up to the top and you click snap, and it puts it into your photo directory on the system. So you just click snap and it's taken that photograph for you now, and it's your photograph. You know, you might be watching somebody doing some really nice observing. You think, I need a photograph of that. You just click snap and it's done it. So, you know, as I say, it's aimed totally at beginners. So, but they do have some interesting star parties and some projects for kids. The one thing I don't like about it is, even if you're on as the, that's well spaced, isn't it? But if you're on as if you're on as an experienced astronomer, they still award you badges for everything you do, and I find that a bit well, oh, you've just won the Ptolemy badge. I've been doing this for 50 years. I mean, I've been doing astronomy now for 50 odd years, and you know, to get a badge for my ventures, I find a bit, you know, off-putting is the word, but it's great for kids. It's great.
Pete, do you mind if I mention, though, on that image there, that scale is in art minutes, isn't it?
Yeah.
So it kind of really gives you a nice impression of it really is 6 art minutes.
Yeah.
Separation. Yeah.
Yeah. Yeah. I mean, it like I say, you know, we wouldn't have had a chance to see this without this, but I don't know what they're playing at, that whether they are getting some problems with the sky. I don't know.
Yeah,
That's really open. But you can see, you can see the scale there by the side. Wonder what moons these are.
And they're looking up now.
Yeah, identify the moons.
Just
And
getting
where-
Stellarium up now. Just
Yeah, have a look where Titan would have been. I mean, if obviously it's Saturn, so one of these could possibly be Titan. Even that, I would expect, maybe.
Yeah, they're saying, Pete, the reason that they're having problems is too many people have logged on to Slew.
I thought, well, that's it, because it's the only place that anybody can see it at the minute.
Yeah, apparently everybody's crammed onto Slew and it's crashed the system. So, yeah, shows how popular it is, though.
I know it took ages for it to load.
Yeah.
But we've seen something.
Yeah.
Of course we have. Let's have a look.
You know,
Horizon spot change the time. Yeah. But Mars is not far from the moon tonight.
No, it wouldn't be.
Yeah, as you were saying, Pete, with as regards as Raza says, what you can do is you can go into the schedules for all the telescopes, and if you don't want to stay up and watch everybody's missions, but you see some in the list, when you go on the telescopes, you can see the queue list. If there's anything you like, you can actually join that mission as we call it piggybacking. And you can join that mission, and then if you click on it, again, like you say, in the morning, your image will be in your, well, it'll be there straight away, a JPEG image. And depending upon the person who's booked the mission, you should later on in the next day get FITS files as well if you want to do any proper processing or any sort of like scientific stuff, if you want to look at it that way. But yeah, it's as you said, it's basically based for the beginners. It's something that you can jump on when it's cloudy, and there's always somebody there. But it's a great community. There's lots of people who are willing to help you. There's lots of clubs you can join for different things. We've got a sun club. There's a moon club. There's variable stars. There's a club that is basically for astrophotography. You've also got a nightscapes photography club, and if you just jump on there, anybody's willing to help you out. We're all levels, and so you know, never be afraid to come in and ask questions or things like that. And but yeah, it's interesting, and you can also join. Sometimes you get collaborations where people will join together and combine all their data over sort of like 3 or 4 days of very dull images, and then process them to get really, you know, distance star things, galaxies, and all that to bring out the detail. So yes, it's an interesting system, but there's lots to do there, and as you said, it's more educational as well. The points you were on about is sort of the gamification to encourage children to play and things like that, to get on there and learn a bit and things like that. So. Yeah, if anyone ever fancies having a look, have a go. It's there is a 7-day trial if you want to try it before you join up.
So all the data is, everybody who takes data is available to every other member. Am I correct?
Only if you've joined the mission. Only if you've joined the mission.
You have to join the mission prior to the mission happening, or is there an archive?
If you want to join any missions, you have to do them. I think it's at least half an hour beforehand.
Yeah, let me go as if I don't know if it'll work because it's crashed. But if I'm going to set up a mission, let's see if it's. Yeah, I think their systems definitely crash.
And one other thing I wanted to know is that when you get a telescope time, do you actually get to control and move the telescope view as you see it up and down? Or do you just say, for example, I want an image of this object, and you wait for the telescope to give you the results?
You book your mission. There's 4 ways you can do it. They've got a Slew 1000, which is a list.
Eli does. I got it up on the screen now. Can you see it? Yeah. So
yeah,
say for instance, I'm going to set a mission by telescope. it's taking time because obviously.
Okay, so you have multiple ways to set up a mission. If you can go a little bit higher, there was. Okay, by catalog, by constellation, and by SLU 1000.
SLU,
Okay.
that's 1,000. If you're on the very basic level, it gives you 1,000 objects you can set up as missions to go and image. If you pay a little bit extra, if you pay the full astronomers level, which is around about, I think it's $300 a year, you get to use all these options. So you can use a telescope, you can buy coordinate, you can buy constellation, you can select your object. Usually, when the system's working, you can set up a mission by clicking on one of these, and it shows you where there's some spare space. But obviously, at the moment, with them having issues with so many people logging in, but you'll get lots of missions here, and then you'll get where it's in blue like that. It'll say this mission's available, and for you to configure how you want, and you just click on it, and then add your object in that you want to image, and it goes away and does it at that particular time. It look like I said, and then it'll show other people's missions. And if you like, I want to join that mission, you just click on what they call RoboSnap.
Yeah.
The one thing I hate about it is they have presets for the cameras, and they don't call them presets for cameras. They call them menus. And it's one big bugbear of mine. It's not a menu. It's or a recipe.
A recipe.
A recipe. It's not a recipe. It's a setting for a camera, and you go on there, and they do. I think they do word it a little bit as if it's aimed at kids. But like I say, for a society who wants to do outreach, it's a fantastic tool for doing outreach with, because you can do live views, you can set up little missions for kids to do, and there are many clubs that the kids can join and get badges. So it is good for that. Yeah.
I'm going to have to bounce out because the inventor of the Oliver scale wants me to play with him for a bit.
Okay. Okay.
So, thanks very much for having me on tonight, and it's been a lot of fun.
That's been great. Yeah, thanks.
Yeah, Alex, I wanted to personally thank you very much for reaching out and introducing me to this great community here. I'm gonna keep visiting, and we're gonna learn a lot. I'm learning a lot, and thank you very much for your great talk. And the program was excellent. And thank you for having me.
Reza.
It was excellent, Alex. No, I enjoyed it.
Oh, thank you. I hope it came through all right, because it's always a bit tricky to get the Zoom, YouTube.
Yeah, no, you did a great job organising this, I've got to say.
Yeah, I did, yeah.
Just got to say, Alex, thank you for including me in this as well. I do appreciate that.
That's okay. Jordan's been an absolute trooper at getting involved as well with this. He's been behind the scenes pretty much every day, just helping out, even with
I'm just sorry that the weather has interrupted. Otherwise, I would have been out with mine as well and providing...
As regards the moons of Jupiter, the two close to Jupiter on Stellarium on the right-hand side, on the left-hand side are Ion, Ganymede.
Yeah.
Callisto further out, and then Europa is the one on the opposite side, near a bright star. And then Titan is to the right of Saturn, but higher up, about 5 past the hour on the screen.
Well, I'm going to unshare that now because their system's completely gone down.
So have a great Christmas, everyone.
Well, what I'm going to do now is I'm going to leave this open for everybody to have a chat and carry on chatting, and you're all welcome to stay. I'm going to now stop the recording and stop the live feed to YouTube.